Hi, thank you for taking your time for my session, Real World Machine Learning. I'm Kaz. I'm a developer advocate. It's like an evangelist for developers. So I usually attending the events or meetups like this, speaking about the products and technologies. Working at Google for over 7 years, and now working for the Google Cloud team. So before dive deeper into the machine learning products from Google, I'd like to discuss what are the differences between AI and machine learning and neural network, those buzzwords. AI, there's no scientific definition what is AI, but you can say it's a technology or science to make things smart or make this smarter computer, like the autonomous driving car or letting computer drawing a beautiful picture. Yeah. And there has been many approaches to realize the vision of AI, and one of them is machine learning. This is a kind of the paradigm shift of programming. So usually if you want to build a new IT system, you have to hire programmers to write the program code that instruct computers how to solve the problem. But instead, now you can just use data instead of human programmers to program your computer. So you can just put more and more data to the computer so that computer somehow tries to find best way to solve the problem. And there has been so many different algorithms for machine learning, and one of them is the neural network. And if you have more and more deeper layers of neural networks, that is called deep neural network or deep learning. And at around 2012, we have been seeing a breakthrough has been happening in the area of neural network. So that's why Google has been spending so much amount of resources and investment in the area of neural network. So let's take a look at how neural network can solve a problem by using this fruit problem. If you have a customer, and imagine that you are a programmer for the customer, and your customer asked you to classify these fruits as an apple or an orange. What kind of program code with Java or C or Python, anything, to classify these fruits? Maybe easiest way to look at the color of pixels. If it's a red, it must be apple. If it's an orange, it must be orange. But your customer comes to you again and asks you, sorry, in the production system, the performance of a camera is not great, so the image would be like this, monochrome. What kind of program code you would write to classify these as an apple and orange? In this case, you have to look at the shape or patterns or texture of those images. And then your customer comes to you again and asks, if you can do that, do the classification with the apples and oranges, maybe you can classify on these images too. Can you do that? With writing Java code or C code, anything. These looks like mops or bloom or something, but if you're carefully looking at some of these images, there are some sheepdogs. You know, the images at the top left or images at the right bottom, they are not mops, they are dogs. How do you classify these images? Actually, by using Cloud Vision API, you can get a fairly high accuracy on classifying these images. In any machine learning algorithms, it's almost impossible to get 100% accuracy. So the accuracy would be something like the 70, 80, 90, 95, or 98. But it cannot be 100% in most cases. But still, the Cloud Vision API does a decent job on classifying these images as a dog or a mop. And how does it do that? How neural network works to classify these images or any kind of data? Actually, neural network is not dedicated for image classification. It's just a function in programming language or mathematics. So you can put any kind of data to neural network to neural network work to solve your problem. For example, if you put images of cats and dogs, you can train the function to classify these images as a cat or dog. And you can replace these cat images or dog images with any other data you want. For example, if you have a database, Oracle database or MySQL database with the customer transaction data from the e-commerce website, you can try convert the customer transactions into a bunch of numbers called a vector or matrix, and use neural networks to classify what customers would be the premium customers or what customers would be the spamming or cheating customers or the the spammers. So that could be one example of use cases of a neural network. Let's see how neural network can solve your problem with the demonstration video. So let's take a look at the video. This is a demonstration called TensorFlow Playground, where you can build the real neural networks inside your browser. So anyone can Google search this with the keyword TensorFlow Playground. So anyone can play with it. So you are seeing gradually neural network can try to classify the data points on the 2D space as an orange spiral or the blue spiral. So in this case, you don't have to write any program code by yourself, like a Python or C or Java code. Instead, what you have to do is put more and more data to the neural network. So neural networks tries to find what is the best way to classify this data as the orange spiral or the blue spiral. So if you spend like a few minutes, like 1 or 2 minutes, the neural network could be fully trained so that it can classify the data points into one of these spirals, just like we do by using human instinct. See? And you can extend this technology to solve many other kind of the problems, such as the image recognition. For example, if you have a handwritten handwritten text images with 28 by 28 pixel images, you can flatten those pixel data into a single vector with 784 pixels of data. And you can put those data into the neural network directly. Actually, this is not a network. This is a single layer neural network. So the most simple neural network design. But still, you can get a decent recognition accuracy, such as the 80% or 90%. So if you train the neural network with this pixel data, the neural network can be trained to determine which pixels you have to look at to determine whether the images should be on digit 8 or digit 6 or digit 0. And if you have more and more layers between input data and the output layer, that is so-called deep neural networks or deep learning. And by doing so, you can get much, much higher accuracy. And sometimes you can get higher accuracy than humans. So, for example, in this case, you have the tens of or dozens of the hidden layers between input data and output data, so that each neurons inside hidden layers can be trained to recognize simplest patterns, such as as you can see, the patterns on the left side, or the complex textures or colors, or a part of objects like a nose of a dog or the wheel in an automobile. Or finally, you can have the neurons that can recognize a whole object, like an automobile or flower or wedding party. That is so-called deep neural network. And Google has been using these technologies for implementing over 100 production services and projects, including Google Search and Android, Maps, Gmails. If you are using Google Search every day, that means you are using deep learning from Google every day. Because in 2015, we have introduced RankBrain, which is an algorithm based on deep learning to determine the ranking of the search results. Which one should be the first, which one should be the second. And now we are trying to externalize the power of the machine learning running on Google Cloud, from the Google machine learning services from the cloud. The first part of the product is so-called machine learning APIs. That doesn't require any machine learning expertise or the knowledge. You can just upload your own images, audio data, or text to the API, so you'll be getting the result within a few seconds. So let's take a look at a few examples of those the APIs. First, we'd like to show a video of the Vision API demonstration. So in this demonstration, you can go to the product page of the Vision API. So anyone can drop your own images without spending any money. It's available free. So if you drop the sheepdog images to the API, you can get the result like dog or dog like mama. Yeah. So let's go to the next video. Yeah, we have another video. This is an example of the demonstration of the speech API and natural language API. So if you press button and speak to the microphone, then it can start recognizing your voice in real time at high accuracy. just like the voice recognition you have in the Android devices. And once you got the result, you can copy and paste result into the another API, which is natural language API, NLA API. That allows you to do many different analysis on the text, such as the entity analytics, sentiment analytics, and syntactic analysis. So by pressing the button, you can get the result of the entity analysis so that can extract the nouns or product names or the company name from your result, or sentiment analysis, whether the statement is saying anything positive or negative, or syntactic analysis, which are the part of the text of each word, noun, verb, adjective. So you don't have to hire expensive natural language processing researchers or data scientists. You can just use the API. So that was the machine learning APIs that requires no machine learning expertise. You can just start using the APIs from today. But sometimes you want to customize the machine learning or neural network models by yourself by using your own data, specifically designed for solving the business model. So that is, to solve that problem, we provide TensorFlow, which is the open source software for machine learning development. TensorFlow is the open source machine learning development tool used inside Google for developing any new machine learning or AI-based services. And we have open source in November 15th. That is created by the Google Brain team. The benefit you could get with TensorFlow is scalability and portability. So you can start trying the product TensorFlow by using your own Mac or Windows. And the TensorFlow has the sample code like the classifying the handwritten text as digits. That could be run on Mac or your Windows because it doesn't require any much computing resource. But you will find that the training the neural network model or deep learning model can take so much computing power or so long time if you really want to bring this solution into production quality. So that's where you want to use GPU from NVIDIA or maybe dozens of GPU or hundreds of GPUs to do the distributed training with production data. But still, you don't have to change your code with TensorFlow because TensorFlow is designed to be scalable. So you can just copy your TensorFlow code and your training data, copy it onto the cloud, where we can provide the tens or hundreds of GPUs. So it's scalable. And once you have finished training your model, you can copy the model. It's just tens of megabytes of data or maybe hundreds of megabytes of data. You can copy that data, the model, to the smaller devices such as the mobile phones or embedded systems or Raspberry Pi, where you can learn TensorFlow, specifically TensorFlow Lite, to run your trained model to solve your problem with smartphones or the embedded systems in your factories or any environment where you cannot get any internet connection. So with those benefits, TensorFlow get the popularity in the open source industry. That is the most popular framework for deep learnings in the world. And the many largest companies, enterprises, and startups and even individuals are starting to use TensorFlow to build POCs or production systems, such as Airbus, ARM, Dropbox, Intel, IBM, the Twitter. Those companies are really deploying the TensorFlow in their systems. And even the Cucumber farmer in Japan has been using TensorFlow. I have taken these pictures by myself about 1.5 years ago. And there are 3 farmers in the picture. The one guy in the middle, he has parents who has been doing cucumber farming for a long time. And he started helping his parents cucumber farming 3 years ago. And he found that the most tedious task, time-consuming task for cucumber farmers is classifying the cucumbers into 9 different classes at high accuracy. His mother spent 8 hours a day just for classifying cucumbers, thousands of cucumbers. And he didn't want to help that. So instead, he downloaded TensorFlow and built his own TensorFlow-based cucumber sorter. So you can put the cucumber on the plate. So the Raspberry Pi that runs the TensorFlow can classify cucumber into 9 different classes. And he built this robotics by himself, and it costed only $1,500. So you don't have to, pay like millions of dollars to the systems integrator to build this kind of high quality, high accuracy image recognition system. You can just have just an individual, the farmer who are enthusiastic about applying deep learning for solving their problems. Okay. So that is the booming of the TensorFlow community and ecosystem right now we are having. But if you want to bring the technology and TensorFlow into production to solve your own enterprise problem, there are some problems you'll be seeing. There are 3 problems. You have to have the large data set, large training data set to train the neural network model. That is actually one of the downsides of using deep learning. Deep learning requires many the training data set. And you have to build a good model on TensorFlow. Maybe sometimes you have to hire data scientists to do that. But the largest problem is the lots of computation. You need to buy more and more GPUs to do the large-scale distributed training to bring the technology into production. So that is the reason why we provide Google Cloud as a solution for the data scientists and machine learning users. We call our data center as the data center as a computer. That means it's not just a bunch of the machines in a building. It's a massively powerful computers. So you can with the networks and middlewares. So any software engineers at Google can run his or her program code or applications on hundreds of machines with executing just one line of the container command. So that is the reason why the Google Cloud has so differentiated from the other cloud. So what will be the result when you run the TensorFlow on the large-scale distributed training environment on Google Cloud? The result is much, much shorter training time, like 40 times faster or sometimes 300 times faster than the other developers. Right now, if you are trying to use the deep learnings, you have to spend like a few days, or some people are spending a few weeks to finish their training with production training data. But for Google engineers, you have to only spend tens of minutes, like lunchtime. If you go to the lunch and going back to your office, then your training has finished. That's the most important factor or the biggest reason why Google has been so successful on deploying the technology into production. We even designed our own customized LSI or ASIC called Tensor Processing Unit or TPU. This is not a CPU or GPU. We designed our own processor just for running TensorFlow or massive amount of the matrix operations between the matrices and vectors. And now we're externalizing all the power of the cloud that runs the TensorFlow as a product called ML engine or machine learning engine. So you don't have to take care of all the GPU instances or TPU instances by yourself. All you have to do is try out TensorFlow and upload your TensorFlow code to the ML engine with your training data, and that's it. And Google takes care of all the cluster management or failure management, everything. And also we provide the hyperparameter tuning, so that allows you to shorten the training time much shorter. So let's take a look at some of the real-world example of the customers who are already using TensorFlow and ML engine. Oh, sorry. The company like Airbus, AXA, SMFG is the mega bank in Japan. Coca-Cola, they has been using TensorFlow for solving their real problem. This is a project called Global Fishing Watch. That is a project for preventing overfishing. The project is collecting over 200,000 of the vessels, and the GPS, they are tracking the GPS position of the 200,000 vessels in real time. They are collecting all the GPS positions stored on the Google Cloud storage and uses the cloud data flow to do the batch processing, and then uses the TensorFlow to ML engine to extract certain patterns from the movement of those vessels or ships in the oceans. So what you get, you can understand, easily count how many ships are actually doing the fishing in each ocean by looking at the movement of the GPS positions. Is it doing trawl fishing or long line fishing or pass seine fishing? This is another customer who are using TensorFlow and ML engine for solving their problem. That is Kewpie, one of the largest food manufacturers in Japan. They were trying to find a bad potato piece the potato block with the black color or the butt shape. But because they are using the very high quality ingredients, it's really hard for the, it has been really hard for the existing image recognition system to find out the butt potato cube. So they has been using human workers to watch out all the potato cubes coming on the belt conveyors all the day. But when they tried TensorFlow, then they were able to get much higher accuracy than the existing solutions. You can hear the sound. So you heard the sound. It sounds like Super Mario Brothers, but it's not Super Mario Brothers. That ring sound tells you the position of the butter potato cubes coming on the belt conveyors. So now the human workers don't have to watch out all the day. You have to, to listen to the sound and pick up the butter potatoes whenever you hear the sound. So it's much lightweight task, and so that they were able to reduce the cost of the human operators significantly. Lastly, I'd like to show the AucNet case. AucNet is the largest used real-time auction provider in Japan. They are handling over 5 million cars every year. But the largest challenge for the users, the dealers, used car dealers, is the classifying those images for each car. For every car you want to enter into the auction, you have to take 20 different images from front or side or back, or the part of the car, like wheels or steering wheels, tires, and put the tags or labels on each images. And so that takes over 15 minutes or 20 minutes by human operators. So that they tried using TensorFlow and ML engine to build the customized image classifier for the used cars. So they have used the inception version 3 model with the transfer learning techniques so that they were able to reduce the number of the photographs or images to train the model for each car model. You only have to have 200 images for each car model to classify those cars at high accuracy. And also, they were able to use the machine learning engine or ML engine to speed up the training time significantly. They were able to get the 86 times faster training time. So end result for the business is much shorter operating time. So they were able to shorten the operation time for enter the car into the auction from 15 minutes to 3 minutes. So let's take a look at the video. So this is the actual systems. So you can upload 20 different images for a car from front or side or tires or part of the cars. And then the systems start classifying these images. But important point of this project is that the AucNet didn't have any expertise on machine learning or deep learning when they started this project. So they were able to find the best partner from the community of TensorFlow in Japan. So they spent 3 or 4 weeks with the expert in the community. So they were able to learn how to build the production quality system with deep learning and TensorFlow. And now this system is deployed in the production environment from last December only by the IT engineers in the AucNet, the subsidiary. So, as summary, we provide 2 different solutions. The first solution is the ML APIs. You can start using those APIs from now. So, because it doesn't require any machine learning expertise, you can just upload your images, audio. Another solution is TensorFlow and the various clouds, the products that provides the one-stop ML solutions to build your customized machine learning solutions. So TensorFlow works with the other cloud products such as the Cloud Dataflow, ML Engine, BigQuery, CrowdStretch to build the whole solutions. And of course, you can still continue to use the industry standard tools such as NumPy or Scikit-learn or Matplotlib. So that's it. Thank you so much.
Hi, everyone. I'm Dan McGrath. I'm a product manager on the Google Cloud team, and I'm going to talk to you today about a new product we've got called Cloud Firestore. So, as a way of introducing Google's newest database, Cloud Firestore, I want to give you an overview of building scalable apps with Firebase. Before we get started, as people are walking in, I want to get to know the audience a little bit better. So by way of showing hands, how many people have used the Firebase real-time database before? Wow, nice. How many people have used Cloud Functions already? Not bad. And because this is about Cloud Firestore, how many people have already taken a look at Cloud Firestore? Nice, that's more than I expected. So for the talk today, I'm going to give you an overview of Cloud Firestore, tell you what it's about, what sort of features and functionalities it gives you. And then I'm going to dive into an example. And I'm going to go through the code in that example to show you how to build an application in practice. And then once I've done that, I'll show you a bit more code on how you can use libraries and frameworks to do a bit more. So Cloud Firestore was inspired by the experience of building the real-time database and the community feedback we've got over the years. So bear with me as I step back a little bit and take a little bit of a walk on the history of the journey that led us to building this new system. When Firebase launched in 2012, it introduced a fundamentally new way of building apps. The Firebase real-time database solves many of the hard problems dealing with app data. Specifically, it does three things very well that makes our lives easier as developers. First, it allows us to access data directly from mobile clients and web apps. Second, it allows us to access the changing data in real time. And third, it allows us to build offline-capable apps very easily. Cloud Firestore does these three fundamental things as well, and I'll dive into why I think it's so important in a minute. At the heart of the real-time database, it does one thing incredibly well, syncing app state in real time with low latency. Over the years, as adoption of the real-time database grew, usage patterns evolved and expanded, and is being used by increasingly larger applications. When stretching the real-time database outside of its core purpose, we run into two issues. The first is around data modeling and querying. In particular, you can't query over multiple properties at the same time. Getting around this involves duplicating data or doing client-side filtering. The second is the real-time database doesn't scale automatically. Beyond 100,000 concurrent users, which means about tens of millions of daily active users, you have to manually shard across multiple real-time databases. Granted, that's a pretty high bar, but we wanted to do even better. Wouldn't it be great if you could build an app that goes from 0 to a very large scale without having to change a single line of code? This is why we built Cloud Firestore. It's a NoSQL document-oriented database that we built specifically for mobile and web applications. Cloud Firestore builds what users love most about the real-time database and combines it with Google Cloud's powerful infrastructure. It's flexible to build all types of apps and scalable to grow to any size. For me, this is really exciting. Prior to Google, I spent many years building complex enterprise systems and tackled problems of moving data between mobile devices and the back-end database. Now, this is greatly simplified, but often I would start with something similar to this. You have mobile and web clients that talk to a middle tier. The middle tier is made up of a web server handling your static content, and then either as part of that or as a separate system, you have an application server that handles all your business logic, multi-legged OAuth authentication, and then talks to the database system in the back end. That's already non-trivial infrastructure that you need to manage in terms of deploying changes to it, sizing the machines, upgrading the operating system, and various components like the web server and database. And at some point, if your app needs to grow beyond a single database, you start adding things like replication and multiple database servers, which is another piece of infrastructure you need to spend your time managing. Now your app's hitting its stride and continuing to grow, you start thinking about disaster recovery and standby systems in a different location. Maybe you've already tackled this. By this time, you've got some pretty hefty infrastructure. You have people working on this, you're spending time on it, and frankly, it's not something that brings immediate value to your users. You're not going to do a press release or a blog post about your new back-end infrastructure and how much value it adds. The reason I love Firebase, and I imagine many of you do as well, is it takes care of all this for you. And now with Cloud Firestore completing this picture to simplify that hefty infrastructure, you can do all this with a couple of incredibly powerful services that you can just drop an SDK into your app to handle. And even though it's really simple to use, you can build some incredibly complex systems with it. You can use things like Cloud Function to integrate into the full capabilities of Google Cloud. Cloud Firestore was a database I could only dream about having available. It would have saved me many months of effort. Months I could have been implementing features we actually wanted rather than being bogged down in designing and implementing the basic building blocks. So now I'm going to dive into some of the details that make Cloud Firestore so special. Cloud Firestore is fully supported in the Firebase SDKs. This means it's available on the web, on iOS, on Android. It allows you to access data directly from your clients, removing the need for a middle tier completely for access control, data validation, and delivery of data between different devices. And all this works seamlessly because of Firebase authentication and security rules that let us control who has access to read and write the data. Now, security rules is a declarative security configuration language that handles data authorization and validation. You can also extend your application on the server side with Cloud Functions. Server-side code can still be very helpful for making fair decisions for our users or including a secret source algorithm you don't want to have on untrusted client devices. We can also coordinate multi-party interactions much more easier on the server side, or do things like autonomous agents and bots. Now, being powered by Google Cloud's scalable, powerful infrastructure, this means you've got access to a globally distributed database that scales automatically with usage. If you're not using it, it doesn't charge you anything. The moment you get traffic, it's there and available for you. Now, it's a serverless system. That doesn't mean there are no servers. That just means Google is taking care of all that for you. Everything from capacity planning, upgrades, and maintenance, we do all that with no scheduled downtime. It's always up and available. And speaking of that, it's very reliable and available. It is a multi-region replication, keeps the app and user data safe, even in the face of natural disasters. It's replicated across regions in case of that disaster without any configuration or management by you. That's right, Cloud Firestore brings you a fully managed, multi-region, multi-master style database, just like you've had in Cloud Data Store for the last several years. And it gives you the strong consistency that we brought to you via Cloud Spanner last year. It's now expected that we have apps that work across both mobile and web. Even when we never plan to sync across multiple devices, there's a growing expectation that our apps will just work. Cloud Firestore makes it easy for customers to transition between devices or even use them at the same time. Syncing is made easier, by data binding between client and server. Writing an app this way makes it easier to make app load seem faster. You can display the minimum amount of data when you load your page, and then render the new information as it becomes available. It's becoming increasingly often for people to expect our apps to work offline. As many of you know, this problem is very challenging because it requires building complex sync and conflict resolution logic. With Cloud Firestore, building offline-ready apps is natively supported. The SDK includes an on-device mobile database that supports and handles conflict resolution. Having a local database means our app functions smoothly, even when it loses connectivity or the connectivity is flaky. This offline mode is available on all platforms, including the web, so you have a consistent experience. Cloud Firestore also lets us structure data as collections and documents. This makes queries much easier to do. We store related data together in a hierarchy. We base this model on what we learned from the real-time database developers. We studied how people wanted to model their data, supporting the most common use cases with patterns that people just used intuitively. So far, we've noticed this reduces the learning curve and gives a data model that's designed to scale. Query performance is based on the size of the result set, which means you don't have to re-architect your application or your data model as your app grows from gigabytes to petabytes. So here I've got a screenshot of the data console UI. In the first column, I've got a single collection called items. And in the second column, I've got a list of documents that have all got a unique ID. When I click on one of those documents, I then display all the fields that are in there. Now, in the items collection, I actually have millions of documents, and this can very easily grow to many millions or even billions of documents, and it will still handle it. When you look at the document, you can think of this as JSON-like data. So let's see what this particular data set looks like rendered on a page. So here I'm showing Cloud Firestore in action. I'm going to dive into the code behind this soon and talk about some of those core features and functionality. For this, we build an offline-capable progressive web app backed by Firestore. The app displays news stories submitted where the community can upvote stories and add comments. It's displaying top-voted news stories over the last couple of days, and it's done with just HTML, CSS, and plain old JavaScript. We serve those static assets via Firebase hosting, but all the content, all the news stories in the comments, the metadata about them, are stored in Cloud Firestore. And we get them directly from the database without that middle tier. There are no other backends involved. We store all those documents in this collection I showed just before. Each news story is its own document and has a bunch of metadata with it, such as the score, the time it was submitted, who the submitter was. OK, let's have a look at the code. I'm going to go through this line by line. The great thing about this app that we made, we spent a lot of time fiddling with the HTML and CSS, but the integration with Firestore was really simple. In fact, the entire Firestore code is on this single slide. So on the first line, I'm just assigning the result to a variable called unsubscribe, which I can use later when I want to stop listening to live updates. The second line is just grabbing a connection to the database or creating it if we don't already have it. I'm then telling it I'm interested in all the documents in items, and I want them ordered by a field that I've called top, which just gives me the ranking on the page. And then because I'm only displaying the front page, I'm only interested in the top 30 stories. The real magic happens on the next line when I call onSnapshot. OnSnapshot sends this query to the server, which then grabs the initial result set, those top 30 documents, and sends it back and gives it to me as data snapshot. I then pass data snapshot to my display function, display stories, that all it's doing is taking that list of documents and rendering that page that you can see. We believe one of the most important features in Cloud Firestore is the real-time nature. So onSnapshot doesn't get called once. It actually automatically gets called anytime the data changes on the server. If a story drops out of the top 30, new stories come in, or even if you change the title of the story, it will call it again, give you that updated data so you can re-render that and just make the app actually live with the data. You don't have to worry about polling and sorting out all that stuff. We can even generate other pages quite simply by changing that code a little bit. So here is how we would display the user profile page, where I want to see the latest stories submitted by myself. I just add a where clause, and it handles it for me. I can even chain multiple where clauses together. So in this instance, I'm not just filtering by the submitter, but I'm also limiting the stories submitted to within just the last year. We do this by attaching the other where clause, and all of the queries continue to work in real time. So keeping that last chunk of code in mind, I want to talk about scalable queries a little bit. As I said before, the performance is related to the size of the result set, not the data set size. So when we look at our database, it could have billions of documents in it. And then I tell it I'm interested in just the collection, which is millions of documents. I then restrict it by myself as the submitter. That's hundreds of documents. I then say, within the last year, we're now down to 5 documents. The query time, the performance of it, will be exactly the same for my database that has billions of documents to my database that only has those 5 documents. And so that's why it's important to think about how you structure your data and allow you to restrict it down to just the data you're interested in. We do this by making indexing really easy. We actually automatically index all your fields for you without any action. And all our queries are served using these indexes. For the more complex queries, you create composite indexes for the fields you care about. And even that, I'll show in a minute, we make really simple for you to do. We have really good documentation on how to structure your data and tips about doing it in our documentation, so I really suggest checking that out. So here's an example of what happens if you try to do a query on multiple fields when you don't have one of those composite indexes. The query fails with an error, but as you can see here, the error message itself has a link to the console that will allow you to do a single click. So when I click on that link or I follow it in a browser, it brings me to the exact spot in the console with all the information to build the required index pre-filled for you. It's a single click, and off you go. This makes developing and iterating really easy and fast. Then when we're talking about offline apps, Cloud Firestore supports this on Android, iOS, and web. We also added we make it so simple that it's literally just a configuration when you initialize a database and say, I want offline persistence. When we're doing the on-sync changes, we pass little bits of metadata so you can know whether the data only exists locally or if it's been submitted to the server. The news stories in our progressive web app are all managed through Cloud Firestore, which means we can cache the data and queries will continue to work even when we're offline. But it gets better. When you're offline, when we're offline, when you create a new item or submit a new story, it will actually show up in your queries in the local device. And when you reconnect or get a network connection again, we'll automatically sync it down for you. So that means when you're offline and people make changes, update titles, you can close your app, close the browser down, come back to the page, and all those rights are still persisted for you. One other little bit of magic we can do, just to give you an example of how you can string all these things together, is I can deploy this very small Cloud Function snippet. Quickly walking through what this does is we're telling it we're interested in Firestore events And specifically, I want to listen to all events when I create a new document in that collection called items. When I detect a new document being created, I grab the data from that document, convert it to lowercase, check for the word Firebase. If it exists, I take that text and I post it to our Slack channel. That is literally all the code you need to send any document, any item about Firebase to a Slack channel. And to show you I'm not cheating, when I look at the post to Slack, it really doesn't have anything to do with Firestore here. All I'm doing is a REST API call to Slack to give it the information. Cloud Functions itself is an incredibly powerful way to do that server-side glue to put everything together. Supported in Cloud Firestore, the real-time database, cloud storage, authentication, analytics, crash analytics, many more. You can really glue all these things together without having to worry about spinning up and managing servers to do this task. And so that was just a quick run through of an example and how you can string all that together. It doesn't seem like much, because honestly, that is how simple it is to hook this into your system. I want to spend just a little bit now about talking about frameworks and libraries. I just showed you JavaScript examples. Those exact same patterns that I show work on Android and iOS as well. You follow the same model. If you're doing server-side development in more traditional VMs, we also have Python, Java, Go, and Node.js libraries you can use as well. So I want to talk a little bit about meeting you where your app is. Perhaps you're an Angular developer. Our community has done an excellent job already of providing plugins and extensions to many of the popular libraries and frameworks that already exist. So in this case, I'm using Angular Fire with Angular and the new Firestore integration they've got. Here you can see in the first one, I've got a home component for rendering the home screen. I'm using the observable pattern. I'm looking at a collection called articles and just grabbing the most recent 20 published articles. Now, the Angular Fire has a very light wrapper over Cloud Firestore, and it's a very similar API, so you should be able to jump between them very easily. In the second one, I'm using routes, so you can look at an individual document and give you a stable link that links your page directly to the data in Cloud Firestore itself. Perhaps you're a React Native developer. The same thing applies here. Using React Native Firebase, you can do the same thing. In your constructor, grab a reference to the collection you care about, and then you can do lots of cool things with it. You add in a new document is as simple as doing ref.add and give it the fields that you want to add. When you mount a component, you can do that same on-snapshot magic that I mentioned and just tell it what method to call whenever data changes. I mentioned the community's been busy. It's not just React Native. It's not just Angular. Perhaps you're doing VR work and you're using A-Frame. Maybe you're a Backbone developer, or you're using Flutter. All of these integrate with Cloud Firestore today. So with that, I want to thank you for coming out here. I hope this has inspired you to go out, try Cloud Firestore, and seeing what incredible things you can build with it. If you have any questions, you can meet me at the office hours area behind the main hall. I'll be in the Firebase session. You can reach out on Twitter with the hashtag Cloud Firestore, or join our Google Groups where we've got lots of engineers sitting in there really keen to hear your feedback and also see how you're using it. So check out Firebase Talk and Google Cloud Firestore Discuss. Thank you very much.
good afternoon. Namaste. My name is Ben Morse. I'm a developer advocate at Google, where my job is to help the web be beautiful and easy for both users and developers. And before I was at Google, I worked on websites for companies like the New York Times, and AOL, places like that. Before that, I was a musician. I took tabla lessons, actually, for a little while and did a little soukatu. So I'm here with my friend and colleague, Raghu.
Hey, good afternoon, everybody. I'm a developer at Google. I work on AMP. And together with Ben, we're going to talk about building an e-commerce site with AMP. But before that, I thought I'd mention that I, too, am a local former Bangalorean. Over to you, Ben.
This is true. He grew up here. So on to AMP, which, as you probably know, is accelerated mobile pages. So why do you want to convert your current site to AMP or build new pages in AMP? What's the point of this thing? Good question. It's mostly because today's mobile sites aren't what they could be in many cases. I mean, they've gotten much better than they were 5 years ago, especially 6, 7 years ago, but sites still tend to be too slow and too complicated under the hood. The thing is that the phone is a very personal thing for people. People use their phones all the time for all kinds of purposes, and they expect everything on their phone to be good, whether it's a messaging app, they're watching videos, playing Candy Crush, or using your website. They expect everything to be fast, responsive, and beautiful, and useful. And if your website isn't like that on mobile, it will suffer. You see over here some stats. There are more stats like this out there. The one on the left is from a study DoubleClick did recently, just taking data from sites that were opted into sharing their data with Google Analytics. And they found out that if a site took longer than 3 seconds to load, more than half of users would just leave. 3 seconds, which isn't that much time. And other stats over here show that most people who think a site is slow or doesn't work well won't come back. They're just gone forever. And also, of course, conversions will drop if a site is slower. Bounce rate gets worse when a site is slower. It's just that people want their phone to work really well and work fast. And if it doesn't, they'll just think it's broken, it isn't good, and they'll just do something else. And in fact, many sites today load slowly. I think that I recently saw that 3/4 of sites, mobile sites, took 10 seconds or longer to load over 3G. And also, they can be unresponsive. Content might display, but JavaScript is still loading, it's still parsing, and it's still executing, which is much slower on phones than on laptops. And so people will tap on things, and they don't do anything. They assume it's broken, they'll do something else. And also, ads may kind of pop in there and displace content. So none of these things are good. Not to sound negative, but also, you can get a site to be faster as a good developer. You people are all smart over here. You know the latest techniques for site performance, how to make things work quickly, but it takes a lot of work to do this. It's not easy, and sites will keep on slowing down and require constant speeding up. So for all these reasons, we created AMP. The AMP project is an open source initiative to make a better web with sites that are fast, that are beautiful, and also can make money. And it's fast and easy, not just for users, but also for you, the developers. It's been popular. There's over 4 billion pages that are in production now that are AMP pages. Over 1 million domains are producing AMP pages, and every week, more than 50 million pages get produced. And now, Raghu will talk about what AMP is a little more.
Thanks, Ben. So we've motivated the reason behind the existence of the AMP project. As you might have heard, AMP stands for Accelerated Mobile Pages, but we're going to soon discover whether the mobile is really restricted to mobile, or if you can make just beautiful experiences on desktop and mobile with AMP. So now that we've talked about the motivation, let's dive into what AMP really is. There are 3 core components to AMP, as you can see on the screen behind me: AMP HTML, AMP JS, and AMP Cache. AMP HTML is a modified version of HTML that you're all familiar with. It consists of a web components library that provides a powerful and comprehensive set of building blocks with which you can make beautiful desktop and mobile sites that are fast, responsive, and not only that, beautiful, user-friendly. The second aspect of AMP, AMP.js, that's the engine that drives AMP. It's a JavaScript engine, and it does things like managing resource loading and implementing best practices that ensure that your pages render really fast. And finally, the AMP cache. It fetches, caches, and serves AMP pages and ensures that what you see on the screen is, in fact, as fresh as possible. Now, for all intents and purposes, the AMP cache is virtually invisible. That is, what you see when you load a page via the cache is a cached version, and in the background, the cache is updated. Now, for pages that are uploaded frequently or hit frequently, this is not a problem. The cache is virtually transparent. But if you have a page that's not hit as frequently, there are APIs you can call that help you manually update this cache. Now, AMP is designed for efficiency and speed, and it therefore must enforce some constraints to ensure good performance. The first thing might surprise some of you. A valid AMP page may not contain any custom JavaScript. You heard me right. Most web pages today contain lots of JavaScript. So what's the deal with this? Well, most of the JavaScript on a valid AMP page is contained inside the AMP runtime, and you in your page use AMP Web Components library and use this JavaScript engine to write your page. Second, you might ask, what about the AMP format? How does it relate to HTML? Well, the AMP format is a specialized subset of HTML, and it does contain several additional features which you'll see about in the Web Components library. And finally, there's a hard limit on the size of the CSS that can be associated with an AMP page. Now, in spite of these constraints, and I'm going to argue because of these constraints, the AMP runtime lets you build mobile and desktop experiences that can delight your users while remaining high performance. So let's take a simple image. In regular HTML, you'd use an image tag. What do we do with AMP? Well, we use AMP image. You're going to see a whole lot of examples like this with the AMP dash in front of it. This is a simple HTML tag. It's part of the AMP HTML Web Components library. The only thing to note here is that by specifying the width and the height of an image beforehand, the AMP runtime already knows the aspect ratio and it knows how to lay out a page. And that's how the AMP runtime makes pages load fast. We also introduce a layout attribute to most AMP components, and by saying that it's a responsive layout element, the runtime knows how to resize this element when the size of the page changes. Let's breeze through a couple more. If you want videos on your page, let's say you want to embed a YouTube video, it's as simple as this little piece of HTML on the screen. Again, specify the width and the height, a responsive layout, and it's as simple as writing a few lines of code here. The JavaScript engine takes care of the rest. You will see an example, and we're going to discuss how to build an e-commerce site later during this talk. And some of the things you will see can be done using the web components I'm going to show you now. The first example is AMP Carousel, where you can swipe images left and right and have a carousel of images, articles, whatever. A sidebar. Most complex websites need to have a menu and a way to get around the website. So AMP Sidebar lets you do that. And finally, if you want to let people share pages from your website, AMP Social Share lets you do that really easily with just a few lines of code. So what you saw just now were just a few of the building blocks that together form the AMP Web Components library. But the library contains so much more functionality, like video players, social embeds, accordions that let you expand and collapse areas on a page, carousels, menus, special effects, and a whole host of things, in addition to doing things like serving ads, tracking user engagement. And now Ben's going to talk you through a way of building an e-commerce site with this Web Components library.
So as Raghu was saying, oh, sorry, I'm not on. So as Raghu was just saying, AMP has a lot of components built in. When AMP first started out, it was made for publishers to use. So it was good for static pages, simple pages. But as he's been showing you over here, AMP has advanced since then. And I'm here to say AMP isn't just for publishers anymore. It can be used to make all kinds of sites. And as Riku was saying, not just mobile experiences, but desktop as well. Many, many kinds of sites are now easier to make with AMP and are just a lot faster for users, hopefully easier for you, including e-commerce sites. E-commerce is a pretty complicated idea, so we're going to discuss actually how to build an e-commerce site with AMP, and that may show that all kinds of things can be done, including, of course, e-commerce. So going on, let's do it. Here's a site over here. This is a bike shop we're going to build for you in the next 19 minutes and 24 seconds. And by the way, this bike shop already exists in a template form on ampstart.com. We'll give you guys the URL later on. And the code examples are modeled after that site. So an e-commerce site. First of all, you need a home page where the user can go there from search, from Facebook, from Twitter, wherever, and they can find your stuff and see what you are, look for things. And then when they found something they're interested in, they might search around, they might use a category and menu. They're going to want to go to a product browse page where they can look at various products and see what they want to actually buy. Next, they actually will click on a product, hopefully, if things all go well, and go to a product details page where they can see the product, what it's like, what it costs, and so on. If they like it, they might try to actually buy it, in which case they'll go to the cart page. And the cart page shows, what's in the cart, what they have, and then finally, the checkout. And then you guys get money. So let's go back to the beginning. The home page. The home page is not that complicated usually in most cases, and the things on this home page over here can mostly be done using pretty standard static type AMP components. So for example, images, we saw AMP image. If you want to have a video of some sort, we have various components for embedding videos. If you want to have a little sliding image carousel showing products or specials, also possible. A navigation and menu, AMP sidebar gives you that. There it is up there, that little hamburger up there on the top left. I guess they call this a burger menu in Germany, not a hamburger menu, even though Hamburg is a city in Germany. Let's pass on that, though. Navigation isn't hard to do, and offers, highlights, mostly possible using standard kinds of AMP components. I didn't include search here yet. We'll get to that. Let's go on to our next page, though, the product browsing page. So here again, you could have these products over here loaded as static products, but maybe at this point, you feel like you want some stuff to be dynamic. Maybe you want to have the freshest product data or prices, and maybe the cache doesn't refresh often enough to have that happen for you. Maybe you want to actually pull these in using JavaScript, using Ajax. But Raghu was saying there is no JavaScript. So how do you do that? It's impossible, right? It's possible. We're going to show you how to do it. And something else, let's say the user wants to go through and maybe filter bikes, certain kinds of bikes, certain brands of bikes. They want to sort by price, filter by color. Again, these are user actions. It's going to require some different kinds of dynamic components. So we have those in AMP now. Oh, sorry. What do we do? The question mark, the burning question. Dynamic AMP, we can do it. So when you think about a page being dynamic, there's two ways where this often would happen, where content would want to change in some way. One of those is simply you retrieve content from the server and display it on the page, whether the user has requested something, whether you just do it because you want to do it. So one way, content is retrieved from the server and displayed. Way number two, the page simply changes in response to user actions. Maybe that content is already there on the page, somewhere in the HTML, and it just gets shown, or a class gets changed, it gets changed in some way. So another way of looking at this is that dynamic stuff can happen either in response to user action or not, and content can come from the client or the server. AMP is user-focused, so in AMP, in general, things change when the user requests them. So here's our heroes today that can do these things, our wonder twins of AMP list and AMP bind. They combine their forces together over here to make pages dynamic. So the cases that we just discussed, they cover these cases. AMP list pulls content from the server, and AMP bind over here looks very, very serious today. AMP bind lets you actually bind components to actions of some sort, so that's the second case. AMP bind is when you change the page in response to user action. So these two things actually cover a shockingly wide array of different ways to change a page. So back to our product browse page over here. If you want fresh product data when the page is loaded, that's a case of pulling content from the server. So AMP list. And then the sorting and filtering is a case where the page just changes in response to user actions. It might also involve pulling content from the server as well, but this is mostly an AMP bind kind of thing. So let's begin with AMP list. AMP list, again, retrieves data from the server, lets you actually format it with a template, and show the result to the user. And as AMP list and AMP bind are friends, AMP list has its own little friend over here called AMP mustache. AMP list, AMP mustache perform together, and Raghu will show you how that works.
Thank you very much. Now it's time to write some code, so pull out your notebooks. I'm kidding. Let's deal with the first problem Ben alluded to, which has to do with retrieving content from the server dynamically. So in this example you see behind me, we're going to start with some product data. And it's just raw JSON data. As you can see, we're trying to build a product site. So there's a couple of items in this JSON, and each item has some data associated with it in JSON format. It's got an item ID, the name that you're going to display on the product page, a description of what it does, a price, which you can update behind the scenes on the server, and an image that you show in your store. Second, AMP mustache. We're going to introduce this. So those familiar with HTML might already know about templates in HTML, the template element. The AMP runtime introduces a new template type. It's called AMP mustache, which is a wrapper around the mustache.js templating system. Now, as you can see here, this template specifies the way a product item needs to be displayed on the page. So we specify things like formatting, what goes in each field, how large the text is displayed, etc. But it's just a placeholder, as you can see. So now let's flesh this out. The next step. Let's add some more details, like a link to the actual product page from the details page, an image of what the product looks like, and as you can see, the double curly braces indicate that it's also a templated element. We specify a height and a width so the runtime knows how big to display it. And now that we've fleshed out our AMP mustache template, let's combine it with AMP list. So this is where the magic happens. This piece of code here, as you can see, contains an outer layer of an AMP list element. The list uses, in the source field, the product components JSON, which was the first code slide we just looked at. And so the list is dynamically populated based on data pulled from a server in raw JSON format. And that JSON that's pulled from a server is populated using the format specified in the AMP mustache template. So this looks like a simple piece of HTML code, and it does pretty complex stuff. And so what we're really doing here is encapsulating this JSON data inside an AMP list. And with this, we've got a product page.
Hey, it worked. She's very excited by this. So there it is, actually, the live page. Here it is, the actual things we showed you a minute ago, those two products in the JSON, caliper brakes, and wheel set. There it is. It works. I might go a little faster because I realize our time is running a little shorter here. So let's go on to the second part over here, because for the filtering and the sorting, we're going to want to use AMP bind. Again, this being an example of the page changing in response to user actions. So binding, as you have in Angular, in React, and so on, is useful. And yeah, there it is, like I just said. And AMP bind has a friend as well. AMP bind works with its constant companion and faithful collaborator, AMP state. Here's Raghu to explain how this works.
All right, let's breeze through this. We're going to solve the second problem here with code. The second problem, namely, changing a page's content in response to a user action. So user clicks, and the page responds immediately, and the contents of the page change with your user input. So understanding how this works can be done in 3 quick steps. Step 1, we call it state. We're defining state, and in this case, AMP bind introduces a custom sub-element called AMP state. In this case, the ID is greeting. So this is an example we're going to go through. It contains some raw JSON in it. And we can index it. So you can say greeting.name, and this evaluates to an expression on the page. So this is a way of putting data inside the DOM of a page. Step 2. We've got to bind this data to an actual element that's on a page. So far, we just had data. Now we have a paragraph element, which is going to be displayed on the page. The thing to note here is that the text property of the paragraph element is in square brackets. And so what happens is the value of that text property is going to be what we evaluate from the expression. So in this case, what I've done is I've initialized the value of the text property with the phrase hello Bangalore. And this is bound to the expression that you see there in double quotes. And that's where AMP bind gets its name. Now the third and most important step, mutation, which means changing the data on the page based on user input. A simple example of how you can interact with a page, a button. In this example, the AMP runtime, and particularly AMP bind, introduces a new method called setState. And when you tap the button, we're going to set the state of the city field to Bengaluru. And the title of the button is correct the city name. So you can imagine how this is going to work out. Let's put them together really fast. To recap, we've got the AMP state, which establishes the JSON data and initializes it. The second step has an element that's seen on the page, and we bind the expression to the value of that element. And third, the mutation, which comes from user input. So as you can see in the animated GIF behind me, tapping the button corrects the name of our old city's name, Bangalore, to our current city name, Bengaluru. And that is AMP bind in a nutshell. Now let's put these ingredients together and see how this applies to the product page really fast. Again, we apply this to the product page example. We've got state in raw JSON format. These are the products. We start off by showing all products from all categories. And then we've got a selector in this case, not a button. And when the user clicks the selector and changes the value, so when you go from all categories to, say, just bikes or components, the magic happens in the background. And thirdly, when we have an AMP list, just putting the source tag in square brackets means it is now bound to the value of the JSON in the page. And here we are.
And there she is. It's working. And that wasn't hard to do, was it? There was no JavaScript involved. There were some expressions involved. But this is a pretty simple way to make pages dynamic. And it works pretty well. Who's this guy over here? Is this like a baseball player with a funny-looking bat or something? Here's
well, everybody knows who this is. Like a well-crafted century that Sachin makes. It took us quite a lot of steps to get here.
Okay.
It's a slow process, but it works.
It's that cricket thing.
That's right. We'll talk more about it. But what we really have as a result of this process of using AMP list, AMP bind, AMP state, is a product page that just serves us dynamic content and supports advanced user functionality. And all this is built from the ground up with AMP with no custom user JavaScript. Pretty amazing.
Not bad.
Yeah.
So we can now make dynamic pages. Let's finish up our site. So again, the idea here is that this is how you can make a site that's pretty dynamic, pretty simply with AMP. So back to our homepage over here, I said before there was no search because we didn't know how to make autocompletion before. And search without autocompletion is like cricket without a bat. It's not good. See, I'm learning things already over here. So over here on our homepage, we have a search over here. We can use AMP form for a validated form over here, which is our search area. We can use AMP bind over here to bind the contents of the search input to an API request. And then we use AMP list for the autocompletion area itself. So the AMP list has the API request in it. It is bound to the search input. When the input changes, the API request changes. You can make a request to the server and format it with AMP mustache and stick it right there on your page. It works pretty well. Then the product detail page over here. Let's say you want to have the user be able to actually choose different colors, different sizes over here. You simply actually bind those the image up there, and there it is. The Add to the Cart button can make a server request. This is a form over here, also possible to do. If you want to have reviews, they can get pulled from the server using AMP lists. If the user is going to actually make new reviews, submit those via a form. Again, AMP list for templating. You get the idea, right? You can do all these things with the various things with AMP bind and AMP lists. And social sharing, as Regu pointed out before, there's a component for that. So Twitter, Facebook, all those little buttons over there, G+, all possible with AMP. The cart page, again, similar. If you want to get shipping costs, you can go to the server for those kinds of things. If you want to change the quantities, you can bind the quantities there to the actual price. If you want to have them remove items, again, you can have binding to actually change classes on things when things are removed. You can have a state variable in there to track what's actually in the cart. And recalculating totals, same idea. Finally, the checkout page over here. We haven't discussed this before, but AMP comes with some very, very nice form validation that's built in. You can specify regular expressions, whatever you want to have some nice, helpful messages over here when things are submitted or things are entered that are not the correct format. And then for payments, this is a new feature that's coming to all browsers. Chrome already has it. Safari is working on it. It's coming everywhere. The payment request API can be used to do this if you'd like. This will pull up over here a nice little screen with the user's devices, the user's actual methods of payment already built in. If that isn't good for you, AMP iframe also can be used. The iframe, you can put whatever you want to in there. JavaScript is allowed in the iframe, of course. So you can do payment also through the iframe. But what if you actually need more? Like Virat Kohli.
That's
right. Actually,
right.
I saw on TV this morning asking for higher wages for cricket players. If you find that actually you can't use AMP for everything anymore and you want custom JavaScript, there are some ways to do this as well. Of course, we mentioned before with the AMP iframe, you can embed whatever JS you want to use. But also, you might find at a certain point that the balance of speed and convenience of AMP is outweighed by wanting to do either more powerful functionality that a PWA has, or we have just more complicated stuff on your page that demands more JavaScript. So this is not a problem here. This lovely animation says it all, AMP, PWA. In this case, it is common to start with some AMP pages for speed, and then at a certain point, transition to a PWA. So you can have PWA features where things load quickly, things are available offline, and so on and so forth. And AMP install service worker can be used to get a service worker loaded and running in the background, so your next PWA page loads immediately. So AMP, PWA are a very powerful combination. As I was saying before, you can try this out yourself over here. ampstart.com/templates has this very same bike template over here that we showed you today. And AMP e-commerce actually works shockingly well. Womp Mobile over in Seattle has been amping various people's e-commerce sites, and the numbers here are usually pretty impressive. A doubling of conversion rates. Numbers like this occur sometimes with raw performance, but not usually. Just AMP is so much faster than anything else that tends to please users quite a bit, as long as the user interface is still nice and the design is still good. Fast Commerce also has made lots of AMP pages and seen pages get much faster and conversion rates increase correspondingly. And actually right over here in Bengaluru is Myntra, which has done AMP e-commerce recently, and they've seen 60% improvement in speed and a very, very large reduction in bounce rates. That's all we have for you. If you have questions, come find us at the AMP office hours or the AMP sandbox over in the other room, other building place. We're here to answer your questions. Thank you for your time, and have an excellent afternoon.
Thank you.
Thank you.
everyone. Good afternoon. So welcome to GDD India. Today, my session is about what's up with the Internet of Things, TensorFlow, and the Google Assistant. So I hope you're all excited to see this. So my name's Wayne Pekarsky, and I'm a developer advocate at Google. And my job is to talk to developers like you about all the cool things that we're doing in this area. So this is a really new area with lots of exciting possibilities, and I really think you're going to get a lot out of this. So there's a lot of different things that we're talking about, but we're going to talk about a concept today called ubiquitous computing. And computing is going to change, and there's going to be all kinds of new and interesting things that you're going to be able to build. And so I want to bring you up to speed with everything that Google's doing in this area and what you can use to do your awesome projects and so forth. So let's get started. So computing has evolved over the years. So we started from mainframes, we went to desktops, we went to laptops, and then to phones. And every decade, computers have gotten smaller and smaller. But clearly, we can't keep making them smaller forever, because then you wouldn't be able to hold it in your hands. If you had a computer the size of a coin, you couldn't touch it or interact with it or whatever. So there's clearly a limit to how small we can make things go. Now, over time, what has happened is that we've also moved into different kinds of devices. So most people nowadays have a phone, but we also have computing devices in cars and on TVs and on Android Wear devices. So computers have gotten smaller, form factors like this, but we're now using them in different ways. We're not using a keyboard or a mouse like we would do before. So we use different devices depending on what we're trying to do. So for example, if you want to write an email, a laptop's the best place to do that. If you want to watch videos, you should use a TV. If you want to use something while you're out and about, use a phone, and then use a wearable while you're walking or when you're not sitting down. So each of these devices has a specific purpose, and we use them for those specific tasks. We don't want to use a watch to try to write an email. That just doesn't make any sense. We're now moving into a world now where computing is going to disappear, but it's going to disappear into all our different devices that we have. So we're going to have thermostats and light bulbs that have computers inside them, and we're moving to a world where computing is going to be everywhere. You're not going to have a device to do something. You're going to just use computing everywhere you go. And we're going to solve problems for people that we didn't even know existed, and we're going to look back on this and go, wow, that was incredible when this certain device came out. And today I'm going to enable you to build that really cool device. So I had someone ask me today, they're like, this IoT thing isn't going to go very far, right? I predict it's going to be even crazier than anything we've ever seen before. We sold hundreds of millions of personal computers, and then we sold billions of smartphones. And in the future, I think what's going to happen is you're not just going to have a couple IoT devices, you're going to have 20 or 30 or 50 devices. And so you're going to have this explosive growth in computing, and this is where your devices are going to be. And so we use the term ubiquitous computing to describe where computing is everywhere, it's accessible wherever they are and whatever they're doing. And so today we're going to talk about the platforms that Google provides to enable you to participate in this, because IoT is going to be bigger than anything you've seen before. So if you thought phones were big, this is the next thing. So let's talk about the kinds of things that Google can offer you to help build your new products. So in the past, we trained users to install apps on their devices. You had one app for each kind of task. And you had an icon that you launched it with and so forth. But now we have devices that don't even have screens. So we need to think differently about computing. We need to think about what it means. We need to think about the user's context, what they're doing, the time, the location, and their physical activity. And that determines how we're going to go about interacting with them and what kind of computing they can do. You need to think of your app no longer as an app, but think of it as a view into a service. And your service is going to be everywhere. So your service is available on wearables, in the living room, in a car. It's going to be everywhere. And that's how you need to think about it. And you need to have a seamless experience. You don't want to have the user use the app and log in on each platform. You want to make it really easy so that they can get started without having to think about the fact that there's different devices. So what do we have to offer you that you can use to help make these kinds of devices to support ubiquitous computing? Firstly, let's summarize what we have as consumer platforms, and we're going to start off with talking about Android devices. So many of you here are Android developers because it's GDD India, and we have many different Android devices that you've probably seen before. So we have Android phones, we have Android tablets, which are very common, and then Android Wear and Android TV and Android Auto have also come out as new experiences, new platforms for people to do Android on different kinds of devices. Now, the cool thing about all of these platforms is that they're still based on Android Studio. You write APKs, and you can do all kinds of things. You can write apps, games, sensor processing, you can do 3D graphics, you can do audio, and many of you write apps for some of these platforms already. And the good news is that if you're an Android phone or a tablet developer, you already know how to write for Android Wear or Android TV. It's literally the same thing. They all support networking, they all support Google Play, and it's very easy to port. So if you've ever thought, what other platforms could I get into, writing an Android Wear or an Android TV app is something that you might want to consider. Android Auto is a little different because you don't write apps that run directly on the screen. What you do is you write templates for either messaging or media apps, and these run on your phone. And the way Android Auto works is your phone plugs into the head unit in the car, and it projects the video and the audio. Alternatively, you can run Android Auto on your phone and mount the phone on the dash of the car. So the nice thing about Android Auto is it provides a simplified user experience to allow people to listen to music and do messaging while they're driving. So we've got lots of different form factors to cover all of the different things that your users might be doing. And each of them are appropriate at different times, while on the go, or in your home in the living room. You also may have heard about the Google Assistant. And so the Google Assistant and the Google Home devices are new ways of interacting with customers as well. And so each of these platforms here are extended by the Google Assistant. So we started off with Google Home devices, but now you can use the Google Assistant on a phone. You can also use it on different platforms, such as Android TVs, Google Pixel Books. It's coming soon to Wear and Auto. And it's great because it's everywhere, and users can just talk to it or type to it to get things done by talking with the Google Assistant. So if you haven't tried it before, you definitely want to check out the Google Assistant to see how it feels, and you can have really awesome conversations with it, and it feels really natural. It's not like talking to a robot, and it's a very compelling experience that makes really nice conversations. So as I said, the Google Assistant works with both text and voice-based inputs, and it has text and voice-based outputs, and it works with the user, whatever they're doing, and whatever they're doing as well. And the good news is that we've launched the Google Assistant in all kinds of countries and locales all around the world. And recently, a couple of weeks ago, we launched the Google Assistant in India for English languages. And these are all the different languages that we support. So you can see we've got a bunch of them covered. And we're always launching new languages, so more are coming soon. So stay tuned if you're interested in other languages. And so the nice thing is that we have coverage for lots of different users all around the world. So those are examples of the consumer platforms that Google provides that consumers have in their homes or in their cars or when they're walking around. So now we're going to talk about what you as a developer can use to participate in these ecosystems to provide services and allow users to interact with your app. Because there are a bunch of new options you're going to find interesting, and let's go through them. So the first thing is that at the end of last year, we announced a developer preview for Android Things. And Android Things is now Google's new platform to support developers who want to build their own IoT devices. And one of the coolest things about Android Things is it's based around this concept of a SOM, which is this board here. So the board's about 2 by 2 centimeters, and it contains the CPU, the wireless chip, memory, and all the important things that makes a device do what it does. And it's on a common board with a common set of software. And you can buy these SOMs in bulk and cheaply, and you can plug them into your own custom boards that are manufactured really cheaply. And the SOM contains all of the expensive, hard-to-design components, and then you can build a small board around it that has your electronics for your application. And so we really want to try to democratize hardware development to make it really easy, because in the past, hardware development has been limited to big companies with large budgets. But with Android Things, you as an Android developer who's experienced with Android and all the tooling can now develop for IoT as well. And you can make your own hardware and participate in the IoT ecosystem that we mentioned is going to be the next big thing. So you start off with a developer board So you can see at the top, we have a developer board there, and the SOM plugs into it. You take the SOM away, and you've got this developer board that breaks out all the different connectors. So it has things like USB, audio, GPIO pins, I2C buses, and so forth. You build your prototypes with these boards. So you plug things in, test it out, and then when you're done, you then make your own custom board that plugs into the SOM, and it allows you to make things that are really tiny, but you can prototype on something bigger as well. And so my colleague Dave Smith, he actually built his own small little LED candle as kind of a basic example of the simplest thing you could build with Android Things. The code for it's on GitHub, so check it out if you're interested. And basically, he prototyped it on the board on the left, and on the right, you can see he manufactured his own custom printed circuit board that shows you how tiny you can make an IoT device. So it's literally this big, and it's everything. It's got Wi-Fi, Bluetooth, it can blink some lights, it does OTA updates, and it's fully self-contained, and it's really easy to work with, and you can develop with Android Studio. So that is the really cool thing about Android Things, is it allows you to make your own custom IoT devices, and you don't need to have a huge budget to do it. And this is something you can do yourself, and all the schematics and source code for this are available online as well. So what makes Android Things awesome is it's based on the power of Android. So you use all of the existing Android APIs that you're familiar with, and it's a variant of Android just like Wear, TV, or Auto. So it's supported by the Android ecosystem and the Android team at Google, and you can use Android Studio to write your code, use all the same libraries and APIs, everything's included. It's also a real Android device, so it includes Google Play services designed for IoT devices. So it's a minimized version that runs, and it has everything that you've used from Google Play services before. As I said before, Android Things is based on a SOM architecture. So the modules are standardized, and Google supports them with what is called a common board support language, a board support package, or BSP. And this BSP is provided by Google, and it's supported by us. And we provide the Linux kernels, we port them over, we maintain them, and we also provide all the necessary security updates as well. So our team at Google that maintains the security updates for Android phones, we also provide the same updates for Android Things devices. And so when a security update needs to be pushed out, Google has the ability to push them out to these IoT devices so that you don't have to worry about that yourself. So you can focus on what makes your IoT application great, and Google handles all the security updates and drivers and all that kind of stuff like that. And we provide an over-the-update mechanism that supports pushing the updates so you don't have to write this yourself. If any of you have developed IoT devices before, you'll know that you have to do your own kernels, you have to build your own OTA infrastructure, and this stuff is very time-consuming and very expensive, so it's something you don't have to worry about. So we see many things that you can do with Android Things. And a lot of people ask me, Wayne, why should I use Android Things compared to a small microcontroller or something like that? Now, microcontrollers are cool because they're cheap and they do simple things like turn on and off lights or control a dial or something like that. But what you can't do with a microcontroller is really powerful things like computer vision, audio processing, and machine learning. These are things that you can't do on a small microcontroller, but it's something that you can do on an Android Things device. And over time, as computing gets cheaper and cheaper, as it always does, IoT devices are going to get so cheap that it's going to be possible to do machine learning and TensorFlow and all these things on super cheap devices in the same way that we use microcontrollers now. And so one of these great examples that we've put together is running TensorFlow on Android Things. And so the same TensorFlow talks that you've seen at this event and at Google I/O previously, all of those things you can run on Android Things devices as well, because we're just an Android platform as well. So we have a sample here that it has a camera and it takes pictures of dogs, and you can see in this example here that when it takes a picture of my dog, it correctly identifies her breed. Now this is not just saying dog or cat, this actually tells you the kind of dog specifically with a percentage probability. And so TensorFlow has this thing called the Google Inception model, which is trained with millions of photos that have been put through the system, and this model is capable of analyzing images and telling you what they are. We have this demo actually set up in the sandbox area. You can try it out for yourself, and we also have the code on GitHub, so you can try it out on your Android Things or on your phones as well. So it's a very simple example of how you can use TensorFlow on an Android Things device. So there's all kinds of really cool applications that you could use this for, and we look forward to seeing what you build with that. Now, we talked about the Google Assistant earlier. It's also possible to extend the Google Assistant. And you can write your own apps for the Google Assistant using Actions on Google, which is our platform that is for developers to hook in their own conversations into the Google Assistant. And we have a tool called Dialogflow. And Dialogflow is a very simple to use user interface tool. It's web-based that you program your conversations into, and it makes it really easy to make conversations. And a lot of people think, well, conversations are easy, you just process some strings, but those are only for simple things like yes or no answers. But if you want to really converse with a computer, you want to have a natural conversation with it. And the Google Assistant supports natural conversations. And in a minute, we'll show a video that shows how this works. So these conversations that you develop, they run in the cloud. They're based on like a webhook that you develop using JavaScript. And they receive text that's transcribed from Google that has the conversation that was spoken to the action. It then gives it to you. You can then decide what the reply will be, and then you send it back. Now, you can do this yourself. You can process the strings manually, but most developers don't want to do that. And so we have the Dialogflow tool that provides it for you. Now, what we're going to do is I'm going to show you a little video that demonstrates sort of a conversation and what it would sound like with a user interacting with it.
Okay, Google, let me talk to Personal Chef.
Sure, here's Personal Chef. Hi, I'm your personal chef. What are you in the mood for?
Well, it's kind of cold outside, so I'd like something to warm me up, like a hot soup, and I want it fast.
All right, what protein would you like to use?
I have some chicken and also some canned tomatoes.
Okay, well, I think you should try the chicken tomato soup recipe I found on example.com.
Sounds good to me.
All right, sounds good to me too. Oops. Okay, so let's look at what we just saw in that video. I was chatting to a Google Assistant then, but that was very natural. I wasn't talking like a robot. I was just like, yeah, I want some chicken soup. It's kind of cold outside, so I want something to warm me up. That was a very normal conversation that you'd have with a person. And the sentences I spoke were quite complicated too. If you look at the sentence, I asked for a hot soup because I wanted to be warmed up because it's cold outside. So I said the words warm, hot, and cold all at the same sentence, and somehow the Google Assistant was able to extract the meaning out of that and get it correctly. Now, if you were writing simple regular expressions looking for the words hot or cold, you wouldn't have got that right because I said too many different words, but it was all about processing the sentence structure. And so trying to process this yourself is really hard. And so the Dialogflow tool makes this really easy. And the way it does it is using machine learning. So the Dialogflow tool, you type in example sentences, like you can see the examples there, chicken sounds good to me, I'd like a cold dessert. You type in different examples, and then it trains a machine learning model to understand other sentences that a user might speak. And so we programmed in some examples like that, and then when we made that video, I spoke completely differently and said different things, but it still understood what I was asking for. And so Dialogflow allows you to implement these conversational interfaces really easily. The graphical tool helps you to identify the entities, and that's it. So it's definitely a tool you should check out to learn about how to build conversations for the Google Assistant. Because when I saw this tool, I was like, wow, this makes everything easy, and I don't have to worry about doing the processing of the conversation myself. So definitely check that out. So with the Google Assistant, we also have the ability to embed it into your own custom devices. So we talked about Android Things earlier. You can run the Assistant SDK on an Android Things device, and you can make your own custom hardware devices that have the Assistant embedded into them. So you could make like toys or robots or whatever, and you can talk to them using the Google Assistant and Dialogflow, and then you can make them move around and do things. And you don't have to implement the conversation yourself. So once again, really easy, and you can embed the Assistant SDK into any of your custom devices. And you may have seen the AIY Projects kit. That works with the Google Assistant SDK. And basically, this kit is just a speaker, a microphone, and a button, and then you've got a device. And so in the sandbox area, you can see some examples we have of the Google Assistant SDK running on a device. And you can embed the Google Assistant into pretty much anything. So that's lots of possibilities for people to try different kinds of ideas. And if you look here, this is the inside of what the Assistant SDK kit looks like. Very simple. And the other cool thing about the Assistant SDK is it works on many different platforms. So we've got support for Android things, but we also have support for just basic Linux machines. And it also works on top of many other platforms because it's portable and it uses what's called gRPC. So I've seen people run it on all kinds of platforms that are not Linux and not Android-based. There's a lot of options of what you can use the Assistant SDK for. So that's some possibilities of different platforms that we have: Android, Google Assistant, Actions on Google, Assistant SDK. But you might want to connect these things up because we mentioned before that it's important to have an ecosystem of platforms that allow people to use your service from many different places depending on what they're doing. So now we're going to talk about connectivity and how to bring them all together. So the Google Assistant supports a new API that we have called Smart Home. And so Smart Home allows device makers, so let's say you're a startup that's making IoT-based light bulbs or thermostats or air conditioners or something like that. Smart Home is the API that you would use to integrate those devices in with the Google Assistant. So we have this concept called a home graph, and it has an API called Smart Home, and you implement the Smart Home API on your service, and then whenever the user says something like dim the lights in the room or turn the air conditioning up, the Google Assistant processes that, and it then sends commands to your service saying, turn the temperature up 5 degrees, or turn the light bulbs up to bright, or something like that. So you implement the API for your devices, and the assistant can then control them. And so from a user's perspective, it's great because they can have devices made by many different companies, and they can communicate with all of them at the same time. And the home graph brings them all together. And so it's definitely something you want to look at if you're building IoT-based devices for common household tasks. And here's sort of a diagram that shows you how it works. You don't write a full conversation like you do with Dialogflow because the Google Assistant handles the conversational part of it. You just implement the API for hooking your device into our home graph, and that's it. And then the user has the ability to speak these commands and then make their light bulbs and thermostats and all these other things change state. Finally, many of you have heard about Firebase, and you've hopefully used it before. So all of Firebase functionality works in Android things, and so it's nice because you can use it on Android, iOS, Android Things devices, and you can use Firebase to implement communications between all these different platforms. And Firebase Cloud Messaging is really important because it allows you to build push notifications to your devices. So if you look at badly implemented IoT devices, when someone adjusts the temperature on their phone of a thermostat, it'll take 5 minutes sometimes for the thermostat to adjust. But Firebase Cloud Messaging implements push notifications so that those changes take effect immediately without having to wait and without having to do inefficient polling. So it's definitely something that you should be using if you want to sync data between devices and do it quickly and efficiently. Firebase also provides a real-time database and cloud storage that you can use to synchronize data, store images and videos and so forth. And it's nice because, once again, it's cross-platform, but it also works on very small microcontrollers as well. So we have some samples, like, for example, github.com, Firebase Arduino, where you can actually implement Firebase on really, really tiny microcontrollers. So not even Android Things class devices, but something very small. And so it implements across all those platforms as well. And so definitely Firebase is something you want to check out because you don't need to implement your own cloud infrastructure yourself. A lot of developers try to build this stuff themselves, and it takes a lot of time. And it's important that you do it securely, because if you don't do it securely, then someone will hack into your service, and then all your data gets compromised and so forth. So Firebase is nice because it handles all the hard aspects of what you're trying to build so that you can focus on building your application. And then at Google I/O this year, we announced what's called Google Cloud IoT Core. The cool thing about Google Cloud IoT Core is it's really designed to scale up to like worldwide IoT device infrastructure. Most companies know how to build something for thousands of devices or tens of thousands, but Google Cloud IoT Core is designed to scale all around the world. And so it's something that the cloud team themselves put together, and it's designed to scale to millions of devices. It has endpoints all around the world so that it handles dealing with traffic coming from everywhere. And you don't need to worry about provisioning, and it adds redundancy to everything that you've built as well. Now, it uses standard protocols like MQTT to get data from devices and aggregate and store them into the Google Cloud infrastructure. And so it's great for enterprise use, and we have a lot of enterprise customers who've asked for these kind of features because they want to roll out millions of devices and they want to have all the infrastructure to handle data coming in from millions of devices constantly, all day, every day. And trying to build that yourself is quite tricky. And then once the data is in Google Cloud, you can then use cloud services such as BigQuery to go and query and analyze these massive data sets to reduce them to something that you can look at and learn more about. So one of my colleagues, Gus Klaas, is here, and he's talking about Cloud IoT in another session. So definitely go check that out if you want to learn about building really big Cloud IoT infrastructures and what's possible with their software. So that was a very big whirlwind tour of all of Google's products to support ubiquitous computing and the Internet of Things. So we hope that it's going to help you to make really amazing devices that are powerful and that are also secure. Because in the past, a lot of companies have built devices that are not secure, and then consumers have their data stolen, and devices get broken into, and it causes problems for everyone. And consumers want to buy well-made devices that get updates and that are maintained so that they can trust them. And so Google's services that we provide that I went through today help to provide many of the pieces that you need so you can fit them together to build the kinds of devices and infrastructure that people want. So we have a sandbox area over in the main area outside this building. And you should definitely come by and check out some of the demos that we have. We have a variety of different Android things, Android SDK, and Google Assistant demos that you can try out and see how they're built and so forth. And also, many of my team members have actually come out to talk to you because we want to learn more about the kinds of things that you want to build. So while we're here to teach you about things, we also want to learn more about what kinds of really cool ideas you've got for things you want to build and how we can help enable them. And if there's new features that you want or something, definitely come and talk to me or my colleagues because we want to hear about what they are and what kinds of things you want. So what's next? We have many different resources for you to learn more. And so we have a bunch of communities on Google+. We have one focused on IoT developers, so Android things, Cloud IoT, different things like that. We have an Actions on Google community for developing for the Google Assistant. We then have an Assistant SDK community for people who are embedding the Assistant SDK into their own custom devices. And so these three communities are great places to ask questions and share ideas. Also, I do a lot of posting on social media. I'm Google's developer advocate for IoT and Assistant and so forth. So definitely follow me on Twitter or Google+ if you want to keep up to date with what's going on. I post a lot about the different tools and new things that we're doing. And so definitely keep up to date with that. So that was a quick little summary of what Google has to offer you. And so I want you to take this away and think about all the different possibilities of things that we could make and what kinds of devices that would help benefit people. So think of people who are less fortunate or might not be able to use a regular computer. They might have accessibility issues. And think about how they could benefit from more computing in their lives and what ubiquitous computing could do to help them perform tasks they can't currently perform or to help make their lives better. So think about this. And as I said before, IoT is going to be a huge thing. It's going to be bigger than computers and bigger than phones. It's going to be way bigger than that. And so you definitely want to be a part of it. So come by our sandbox and say hello. And I'm really excited to see what you build with this. Thanks for coming. All right. Thanks a lot. I'll see you later.
Okay. Hey, everybody. Pardon me, I've got a bit of a sore throat, but my name's Dan, and I'm a developer advocate for Dialogflow and Actions on Google. And during this session, we're going to look at how you go about building an app for the Google Assistant. So let's start by introducing the Assistant platform. At Google, we believe the future is AI first, and we've been investing heavily in the areas of machine learning, speech recognition, and language understanding. So these things all come together in the Google Assistant. And it basically allows you to have a conversation with Google that helps you get things done. Because of these investments in AI, the conversation can be completely natural. You just use your voice, ask in a natural way, and the assistant will help you. So what does this mean for a developer? Well, the Assistant platform has 3 parts. The first part is the device being used to interact with the assistant. So it could be the mobile phone, Android Wear Watch, a Google Home smart speaker, or many other devices. And the Google Assistant is the conversation between the user and Google. They can get things done just by talking with the assistant, and there are many things the user can do just by using the assistant directly. But the third part, which is Actions on Google, allows developers to extend the assistant. So a developer can implement an assistant app, and this is what we're going to focus on today. By the way, the assistant is available in many different languages. We're launching new languages and locales all the time, so you can support many users in different languages all around the world. And we actually just announced support for Indian English. So how does an assistant app work? Well, we built an example around a personal chef, which is an app that suggests recipes based on what you want. First, the user needs to invoke your app. So they say a phrase like, "OK, Google, talk to personal chef," and the assistant will introduce your app. From this point onwards, the user is now talking to your app. Your app generates dialogue output, which is then spoken to the user. The user then makes requests, your app processes it, and replies back again. So the user has a two-way dialogue until the conversation is finished. So I'm going to show you a quick demo of this app called Personal Chef. So you may have seen this video before, but we're going to dive into it a little deeper today, or this afternoon.
Okay, Google, let me talk to Personal Chef.
Sure, here's Personal Chef. Hi, I'm your personal chef. What are you in the mood for?
Well, it's kind of cold outside, so I'd like something to warm me up, like a hot soup, and I want it fast.
All right, what protein would you like to use?
I have some chicken and also some canned tomatoes.
Okay, well, I think you should try the chicken tomato soup recipe I found on example.com.
Sounds good to me.
All right, so that demo conversation was actually quite complex. Wayne said cold, warm, and hot, all in the same sentence, but the app managed to capture the correct one. So could you imagine trying to write a regular expression or a parser to try and extract meaning out of this? There are so many difficult cases that it's basically impossible for anything that's not trivial. So let's see the various ways we could build this interaction. One option is to use the Conversation API and the Actions SDK. So your Assistant app receives a request containing the spoken text from the user as a string. Google handles the speech recognition for you, and then you pass the strings, generate a response, and Google handles speaking this back to the user. However, as we just mentioned, passing natural language can be really difficult. Fortunately, we provide tools that make this kind of thing really easy. Dialogflow is one of these, and it's a platform that makes it incredibly straightforward to build conversational experiences. You might not even have to write any code. So we're going to give you an overview of it today, and it's what most of you should use for implementing your own Assistant app. So what is Dialogflow? Basically, it provides an intuitive user interface for creating conversational experiences. You program in a few example sentences of things that a user might speak, and you can specify which values you want to get from the user. It then uses machine learning to understand the sentences and manage the conversation. So the key part here is that you no longer need to process raw strings. Dialogflow does this for you. You can see here where Dialogflow fits in. It handles the conversation invocation and fulfillment, like in the earlier diagram. Dialogflow handles the conversation for you. So once the user is talking to your assistant app, they then start off with something that we call the user says phrase, like, find me a recipe for homemade cannoli. The Google Assistant and Dialogflow then process this, find the appropriate intent to handle this phrase. The phrase is processed to extract entities, which are important pieces of information that you're looking for. And it then calls your webhook with these entities and the action name, and the webhook can then do something with it and generate a response that is spoken back to the user. So let's see a quick demo of what Dialogflow can do. All right, so in Dialogflow, we create an intent to represent each thing the user might want to do. In this case, we've built an intent that covers the user asking for a recipe. So here you can see how we've provided examples of different ways the user might express their desire for a recipe. These examples are used to train a machine learning model that can recognize what the user wants. So as we add examples, Dialogflow will automatically pick out important concepts that are mentioned by the user. The system understands many concepts by itself, but you can add custom domain-specific information, like in this case, recipe ingredients. So I'm going to add a couple of examples here. So how about, do you have any ideas for chicken salad? Or, I want a quick starter. We can also mark this information as required, so our app will automatically ask the user if they didn't mention it. So I'm going to save here, and we're going to give it a try. So if I ask here, I want something with beef. We mentioned beef, but the agent also wants to know a vegetable and a dish type, so it's automatically asking for them. So let's add these here. Potato. And it asks, what kind of dish do you prefer? So let's say main course. All right, so now we could be suggested a recipe if the server looked this up on the back end. So it's amazing to be able to conduct a conversation dynamically on the fly without knowing ahead of time what the user will say. Once the intent has captured all of this information, it becomes available for you to use on your back end, where you can make stuff happen and generate a response. And once we're done, it's only a few clicks to integrate the app with a load of different platforms. We want to integrate with Actions on Google, so we can just click here and load up the simulator to test it out. So this tool allows us to try out our action. So I can say, talk to my test app. And now we're talking to our action. So I can say, let's try a recipe with chicken. Oops, and I misspelled it. And we'll have potato. And we want a main course. So it's the same app now available in the Actions on Google platform with just one click. So this is the workflow for building an action. It's super fast and simple, so you should definitely give it a try. All right, so that's the end of my demo. So let's talk a little bit more about the platform. All right, so we've heard about how apps for the Google Assistant are built, but how do we make sure we build apps that users will love? Google offers a ton of tools and features that will help you create a magical experience for your users. The most important thing to think about is the design of your app. Voice user interface design is a huge topic, and we don't have time to cover it in this presentation. But fortunately, Google's developer website has a ton of content available that can teach you how to think like a designer and build experiences that feel natural and fun to use. This should be the first place you go when you're designing a new app. Let's talk about some of the platform features you can use to delight your users. Your app can support simple audio output on both the Google Home or other smart speakers or a mobile handset. On a mobile device, you can also craft special responses that make the most of your device's screen. At the most basic, you can specify on-screen display text that is distinct from the spoken response. To guide the user in responding, you can provide suggestion chips. These supply suggested answers to a question that can be chosen with a single tap. And then basic cards allow you to display substantial on-screen information in the form of images, text, and a hyperlink. The text there doesn't have to be spoken out loud. You can also use lists and carousels to provide a visual selection mechanism for users. A carousel shows images, titles, and descriptions for a small number of options. And a list has capacity for substantially more, but the images are a lot smaller. You can also affect the way your app's speech sounds. You can place sound effects, alter the rate, pitch, and volume of speech, and control how words and numbers are read aloud. You can even layer background music and sounds, and you do all of this through SSML. You might also have a conversation that needs to know the user's name or location. So here's one example of finding a local bookstore, and you need to know the zip code. You can use our SDK to request permissions for name, course location, and precise location. And when you invoke this function, the assistant will ask the user for permission using your app's voice. If you'd like to link a user with their account on your own service, and you have an OAuth server, the Google Assistant can prompt users to link their account. At this point, the requesting user receives a card at the top of their Google Home app on their phone that provides a link to the login page. Once the user has completed the account linking flow on your web application, they can invoke your action, and your action can then authenticate calls to your services. It's worth noting that the OAuth endpoint needs to be one that you own rather than a third-party service. If your experience involves shopping or payments, we support rich transactions and allow you to accept user payments. The really cool part is that customers can use whatever payment information they have on file with Google, so payments can be super easy. There's no need to fumble around with a credit card or read numbers out loud. Transactions also supports a shopping cart, delivery options, order summary, and payments. And the user can see a history of all of their transactions. The Google Assistant also supports home automation via our smart home integration. Device makers can easily integrate their existing devices with our home graph. The home graph knows the state of all connected devices, so when you ask to dim the lights a little bit, it knows how to do that. So the user can make all kinds of requests, like make it warmer, turn off all the lights, how many lights are on. The possibilities are endless here, and we plan on adding many different device types very soon. We've also announced the Google Assistant SDK, which enables you to embed the Google Assistant into your own custom hardware projects. And we've created the AIY Projects Kit from Google, which provides a cardboard housing with a button, a speaker, and a microphone to wrap around a Raspberry Pi, which uses the Google Assistant SDK. And at Google I/O this year, we demoed a mocktails mixer from our partner DeepLocal, which embeds the Google Assistant SDK as well. So you can walk up to the device, tell it the kind of drink you want, and it will mix it up for you. So you can really mix the Google Assistant into pretty much anything. So you've built a great app. Now what? How do you get it in front of users? The basic way to access your app is invoking it by name. So when you submit your app, you can provide a set of trigger phrases that the assistant will recognize as a request to speak to your app. As mentioned earlier, you can also support deep links, so users can ask your app for a particular thing. In the long term, users will be able to find your app based on its specific capabilities. If they ask to play a game, the assistant will offer them a few options from the assistant apps available. We also have a directory where users can explore the apps that are on offer. Users don't have to install or pay for anything. All the apps are available just by asking for them by name. Finally, you can hyperlink to your app from just about anywhere. So you can share it in social media, promote it through your site or apps, or encourage press to drive traffic to your assistant app. If a user clicks the link, they'll be taken to a screen where they can read about your app and try it out. So hopefully you're feeling excited about building your first app for the Google Assistant, but how do you get started? Your first port of call should be the Google Developers page for Actions on Google. You'll find guides to getting started with building your first app. With templates, you can actually build an app without writing any code. So you just fill out a spreadsheet with questions and answers, and you can create your own trivia, personality quiz, or flashcards game. And on our Code Lab site, we provide a variety of tutorials that will guide you through creating your first app for the Google Assistant using Dialogflow. We're also offering some incentives through our developer community program. So when you create and deploy your first app for the Google Assistant, we'll thank you with a free t-shirt plus $200 of Google Cloud credits every month for a year. If you'd like to dive deeper into the platform, there's a talk tomorrow on new features and advanced topics. So it'll show you how to do things like layering audio and sending push notifications to your users. I definitely recommend checking it out. And finally, when you want to discuss this with other developers, we have the Actions on Google developer community on Google+. We post regularly there to keep you up to date with the latest news, and we answer questions from developers. We also have a great community on Stack Overflow, so if you have technical questions, definitely post them there. And we're active on Twitter, too. So our team is going to be hanging out in the sandbox area, and we'd love for you to stop by and chat with us about building for the Google Assistant. And you should definitely attend the talk tomorrow, which is called What's New with the Google Assistant. So thank you for coming, and enjoy your time at GDD.
Good afternoon, everyone. Wake up. My name is Amrit. I work as a developer advocate in the developer relations team here at Google. And today we're going to see something really interesting, Firebase predictions, and how you can get actionable insights from that to build amazing experience for your apps. So before we start, let's play a math game for some. Don't worry, it's not going to be too complicated. If you have already seen this before, just play along. Don't spoil the fun. Think of a number between 1 and 10. Don't tell anybody, just keep it in your mind. OK? Multiply that by 2. All good? Plus 8 to it. Really tricky? No, right? Plus 8. Don't worry, it's not going to be too long. Divide this by half. By 2, half of it. And minus the original number that you thought of initially from the result that you got right now. You have your numbers? OK. Now, you must have most probably got a number between 1 and 26. You want to convert that to a character. Now, if you've got 1, that's going to be A. If you've got 2, it's going to be B, and so forth. OK? All converted to character? Now, pick a country, any country, that starts with the letter that you thought of, the character that you have actually got right now. Don't say that out loud. Hold on. Now, pick the next character from that alphabet queue. So if you have A, pick B. If you have B, pick C, so on. OK? Pick the next character. Now, think of an animal that actually starts with the letter. All thought of? Now, the thing that we're going to try and do here is to kind of think of or predict what you guys have thought of. How many of you thought of an elephant? Just show of hands. Good number of people. How many of you thought of Denmark as a country? Again, a good number. How many of you thought both of that? Again, the same number? OK. You guys are a very predictable audience. Well, interestingly, there are no elephants in Denmark, it seems. That's a new thing that I learned. But it feels magical, right? This is how you want most of your app experiences to be like, where you have those emotional connects with those apps so that you retain those apps more. You want to spend on those apps where those magical experiences come in and delight you every now and then. Now, some of you might have thought of something else. Could be an emu, but that's fine. There will be outliers in every predictions, so that's not, we love everyone, so it's fine. But let's think of building a game along these lines that we talked about right now. If you have actually seen, we had the elephant, so let's think of the game's intention for this elephant to go around the world and say collect bananas. But if you look at the funnel of this game, there might be something interesting that you'll find. Within 24 hours, for most games, within 24 hours of acquiring some users, a bunch of users, you're going to lose half of them. That doesn't end there. 7 days later, most probably you lose another half. And 30 days later, another half. This is a worrying trend. And yes, the elephant's not going to be happy. You've done a lot of work to acquire these users, and then you're seeing that these users are getting lost over a period of time. Now, you can, as a product manager, as an engineer, you can think of ways in which you want to retain these users that you're going to lose. You can come up with new strategies, maybe new workflows by which you retain these users to your app. But in order to do that, you might most probably want to know who is going to leave, because it's easier to retain somebody who's about to leave than getting the users who left, getting the users who get back after they have left. But identifying those users is going to be pretty tricky, because they can be any bunch from your user set. But that's where Firebase prediction starts coming into picture. Now, if you've started using Google Analytics for Firebase already, it is pretty straightforward. All you do is go ahead to the Firebase console, click on the Predictions tab, say you opt in to work with Firebase Predictions. And that's all the work you do. From then, we actually take the data from your analytics that you have actually logged in over a period of time, and then run it through an ML model and show you predictions. This is all the code. There's no code that you need to write in order to do it. Just click on the button in the Firebase thing that you're in, and you could start getting default predictions for this. Now, let's get a little deeper into how this is happening. Now, if you look at it at the heart of this problem, this is a supervised learning model. Standard way. We take the past 100 days of data, we divide into 2 segments. One, that for the last 7 days, we know what has happened, so we label that data. And for the data before that, we actually study the user behavior and then validate it against the labeled data. And then using these 2 things running into a TensorFlow model, we would be able to predict for the next 7 days what the behavior would be like. So we have the training data as well as the holdout data. The training data is used in order to understand the behavior of the users based on past history. And at every step of this training, we use the holdout data or the evaluation data to ensure that we have the right accuracy and we can feed back data into it. Now, using this learned model, we can then predict what would happen with the existing set of users for the next 7 days. And that's how predictions are actually formed and shared with the app. Now, using this, you have Firebase data from TensorFlow, then flowing into your Firebase predictions console with one check, which basically that there is an internal threshold for the accuracy. Once the accuracy is crossing that, we then share it to you on your console. You can use that prediction and the data and then act upon that. Now, it doesn't stop there. You can go ahead and use that and then use it with remote config, push notification, or A/B testing. So the advantage of this comes in more strongly when you use it with other tools that are along with Firebase. So you might be able to change something in remote config based on the segment that you got or the prediction that you've got, or you would be wanting to send push notifications to a certain set of audience based on the prediction that you've got, or run a different A/B test on one of the segments which is predicted. Let's look at the default predictions. By default, you get a few things. And you can also write some custom predictions. But let's start with the default predictions. Now, this is how a prediction card comes up. This is a prediction for an app for churn and not churn. Like whoever is going to leave the app and whoever is less likely to leave the app. Let me show you the different sections in the card. Now, first is the name, what the prediction is about. Here, it's not. The second one is where users are not going to churn from your app. Then you have a percentage of users that you would see from your current user base who are predicted to churn in the next 7 days. 36%, that's really high, so you need to do something about that. Now, you would also see that 36 plus the not churn, they are not adding up together to 100, but that's fair, because there are some users in your system which we don't know enough data about, and we would not predict for them. So sometimes these numbers won't add up to 100. So there'll be a set of users that we have not learned enough data to understand some behavior from them. Now, the next thing that you want to look at is the number. So we also show not just in percentages, but when you take a targeted percentage, what is the total number of users that will be affected or that is actually in this segment right now. Now, the second prediction, this is even more interesting, is who is predicted, who the prediction by which you can say, is this person likely to spend on the app, or is this person not likely to spend on the app? This can again be used to create some powerful workflow changes by which you can increase the revenue. Now, if you see, there was a slider which said, which was there in each of these cards. This is basically a risk tolerance slider. Now, this is a way of you to tell the system how tolerant you are to false positives. Now, by changing this, you will change the value, the number of users targeted, and the percentage. So let me explain that with an example in there. Now, if your risk tolerance is low, which means that you have low tolerance to, say, something like the risk that you want to take with the action that you take, you want it to be really low, and you don't want any false positives, then you can share it to be low. Or if you want to the risk can be taken, a lot more risk can be taken, you can set to a higher risk level. Giving you an example, if I'm going to target in this app, I'm going to target all the users who are about to churn, for example, and I'm going to give them a free gift. Or rather, let me take another example. Let's talk about somebody who's already spending, and you're putting a new in-app purchase in the app. You want to kind of show it to users who would actually more likely to purchase that, right? You don't want to show it to non-spenders. So when you take that, you can take a higher risk, because even if you show this new in-app product to a user that is not likely to spend, it's still fine, because at the most he's going to not do any action on it, but there's no loss of revenue or anything for you by taking that risk. So you will actually try to give it to a maximum risk tolerance. But in the same way, if you think about giving a free, say, a free product or a free subscription to everybody in the game who's about to churn to increase retention, you might want to give it to a low tolerance, because you don't want to kind of give this free to a user who's anyway willing to pay for this. So then you want to use risk tolerance to be minimal. So that's how you want to use the risk tolerance slider to kind of change your value. Now, overall accuracy, that's the last part in the card, because we know what happened and we know what we predicted. We kind of use that information to kind of tell you how accurate this prediction has been over the past. It takes the last 14 days and then shows you all the positives, positive scenarios and the negative scenarios, and calculates the overall accuracy. That's the accuracy card. So sometimes you want to take into account the accuracy before you decide on your risk tolerance, or decide on whether you want to act upon that prediction or not. If the accuracy is really low, maybe you don't want to kind of take into account that one. Now, how would you use predictions in your app? Now, let's take an example in this case where let's take an example where your users are likely to predict and we want to do something about that. Now, we know from our app's data that, hey, at the level 4, if people have actually crossed level 4, they have an emotional connect with the app and they tend to play more because there are more options available, there are more gameplay choices. So you know that retention is higher after level 4. So that's a fact that we know. Now let's see how we can translate that with a prediction that we have made so far. Now you could use the prediction churn where you had 36% of people who are likely to churn, and you could actually use remote config to do something like this. We could change the game difficulty for people who are more likely to churn. Like in this case, predicted to churn, and when the user is below level 4, you change the game level difficulty to easy, only for those users, without affecting the gameplay for everybody. You're not changing for everyone, you're only changing for the people who actually are predicted to churn, which means they will find it easier to go over level 4, which means the retention would increase. For everybody else, the default medium would be default medium level is what we want to keep. So that way, for people who are enjoying the game so far and are not predicted to change, predicted to churn, you would continue to give them the same level of difficulty, but at the same time, those who are actually predicted to churn will be given an easier way to kind of play more and go over level 4. Now, for prediction of spend, let's think about how we can actually improve that part. There's a prediction spend that 22% of people are willing to spend on it, which is a good number, so we should try and improve that. One thing that you could do at that point is to kind of use A/B testing tool to decide what would be the quantity of a certain EAP and what would be the best price that people are like looking at. In this case, there are 2 variants that you can run against the people who will spend. You could run a variant A, which actually gives you a dozen bananas for $1, 0.99 cents, or 10 dozen bananas for $5.99. So if you want to find out what are people more likely to buy, you want to kind of send it only to the users or enable this only for the users who would actually pay for this, right? The risk of running this for everyone is that your A/B test can be inconclusive because a lot of people are not buying it anyway. So you will actually not be able to get very conclusive data on it. By limiting it to the users that are spending, are likely to spend, you get a much more accurate way of measuring this and deciding which one of these variants should you continue to keep. Once you see that, hey, variant B is what most people want, what you would do is just use that throughout the app. So the A/B test result would be based on how users are using it and segmenting it to the right audience. Now, you also have 74% of people who are not paying. That's a non-spending group. Here, you could use an alternative monetization model, which could be a rewarded video, for example, so that you can increase the revenue from people who are not even likely to spend. So if in-app products, they're not buying it, maybe you want to kind of show them a rewarded ad by which the revenue increases. They might get some benefits out of the app. You might open up some levels or things like that, but they still are generating revenue for you. So this is also quite powerful because you now target people based on what they are how they would actually generate revenue for you. By showing a rewarded ad to everyone, your effectiveness is less. Or by showing that A/B test to everyone, again, the effectiveness is less. But the effectiveness suddenly jumps up when you actually target them correctly. Now, there are also custom predictions that you could do. Not just the default ones. There are 5 custom predictions that you could do where it's as simple as this. Let's look at the flow of how you make a custom prediction. You start by taking one of your conversion events that you have logged already. So when you log analytics, you can say that to be a conversion event. And then you take one of those conversion events, then share, like in this case, I've taken whether somebody would share some data or not. So you want to show the share dialog only to users who are more likely to share it. For others, it's always a level that you could, or a UI that you could actually skip. Now you want to introduce social engagement in your app, and you want to show it to users who are interested in doing that. Now, I've taken a prediction, I'm taking a prediction of social engagement, and I'm looking for people who will share. Once you actually get that, say in this case, there's a 30% of people who are willing to share that. Now, with that data, you could then turn on, using remote config, maybe turn on a screen which would show them the search interface for them, share interface for them. Now, just don't take my word for it. Let's look at some examples of how people have actually used this and made some changes in their app in the real world. Halfbrick, which is one of our partners who worked with it, increased retention for their Dan the Man app by about 20% by using Firebase predictions. Let's see what they have done. So initially, they went ahead and said they were going to use Firebase predictions, and they've opted in for Firebase predictions. Now, Firebase predictions in the background actually started preparing this, and once the predictions were ready, we sent them a mail. You click on the mail, you open the console, and in the console, you get predictions of who's going to churn, how much, what percentage, so 23% in this case. What they did is then clicked on Target Users button, showed up remote config as an option, and they used remote config in this case. They created a parameter, will churn, and then published it. Now, by doing this, what they have done is, in their app, they now have a parameter for that. Every user, in the next remote fetch, every user will get one more parameter which says whether that person will churn or not, which means the app right now has the intelligence to decide whether this person will churn or not based on the prediction that happened in Firebase Predictions console. They did an algorithm like this. Let me not read the code, but I'll tell you what they did in picture. They actually shared a special gift for people who are about to churn. They gave them a little bit of coins and a play button, which is very enticing. So by doing this, only to the people that were about to churn, they reduced the day 7 retention by 20%. 20% is not a small number to kind of keep back, right? So there might be many instances in your apps where you can actually do things very similar. Let's take another example where somebody has optimized revenue based on predictions. Now, Rockbite actually is one of those apps that we worked with who increased their revenue by using Firebase predictions. Now, what they did is they basically used the predictions, the spend prediction, and changed the order in which goods were actually shown in A/B testing. Sorry, in their digital store. Now, they used A/B testing tool to kind of do that. What they did has amazing results. They increased their revenue for spenders by 25%. That's 1/4 increase in revenue. Not a small number that you can ignore, right? Now, what they had done is they used this condition and ordered differently the way in which they would keep digital goods the in-app purchases in their app, the in-app purchases that I had, and the order is actually changed based on this data. Now, for the spender group, they actually gave rare items. That is a chest that you see up front. And for those people who were not spenders, what they did is they gave things that could continue gameplay for a longer period of time, like crystals, for example, which can be used within the game. So that by which, this is more interesting, for that 72% that did not spend, they increased the revenue by 24% for people who were not willing to spend. So this way of actually changing things using A/B testing tool, it allowed them to kind of do this and increase revenue on both the spenders as well as the non-spenders, thereby both getting customized experiences which made them spend more. Now, Concrete is another example that I want to share with you, is another partner who actually improved their users' experience by showing them ads showing them ads to users that were actually were more likely to retain more ads, and less, as people are about to churn, they reduce the number of it. And they gave this clearly with a very user-centric approach. They were able to increase their in-app purchases by about 21%. In summary, this whole thing, if you're already using Firebase Analytics, if you're not, start using it. If you're already using that, opt in for Firebase Predictions. With Firebase Predictions, you would be able to find out these interesting bits by which you can change your flows and improve experiences for user, make it very customized, and get Google ML to work for you as part of your team. So that's a star photo after you add Firebase Predictions to your team. We are also part of that. Now, this doesn't end there. It's not just about predicting the user behavior. It's also about using them with appropriate workflows. Use maybe push notification, where you push notify to users based on their behavior. You might want to send certain users who are, based on your prediction, that segment of users, one type of message and a different one for different segment of audience, or maybe change a remote config and change the behavior of the app on the fly. Or it could be that you can run A/B tests on the more appropriate set of people that you have. So the power really comes in when you use it all in combination with each other. And if there are more questions, please feel free to meet us at the Firebase office hours section. And I hope this was useful for you guys, and you're going to try it out. If there are interesting cases that you come up with, please do not forget to let us know. Thank you.
Hi, everyone. Hello. Good evening. It's been a long day, and hopefully you had a lot of good sessions since morning. This session, we are going to actually start with understanding containers, Kubernetes, and yes, as well as Google Cloud. So just before we start, just a word of to understand where we are. How many of you know about containers? Excellent. How many of you know about Kubernetes? Excellent. And Google Cloud? Yeah, I mean, you are experts than me then. You already know everything. But let me try to give a different perspective. So this is our agenda. We'll try. We are not deep diving into Kubernetes as a whole or understanding the bits and pieces of Kubernetes, but we are trying to understand why Kubernetes got out or containers got out, and what is the use case of these containers, and why we have to use them. And yes, I'll also show you how easy it is to create a Kubernetes cluster, and I'll take you to Google Kubernetes Engine, which is managed Kubernetes cluster. And we'll wrap it up. So if you understand the current practice, how we create applications, generally it's been quite some time we have been doing the same kind of application development. If you look at the current application practice development is, we have a couple of web servers where you put your code on, and you have a database which the web server will be calling continuously to the database. And there will be always a batch processing happens from the database to whatever you wanted to basically churn the data out. And you have a cache where you have your caching requirements. This is a traditional app. And what is the biggest challenge you see if you are building these kind of applications? Point number one. How many people here had an issue of you waiting for the test team to deliver, or test team waiting for the developers to complete the code and give it to you? How many? Few of them, right? This is a common issue. And the second one is you have a couple of pieces or couple of modules in your application which are dependent or not dependent to each other, but still you have to code them, wait for the build to succeed so that you can push your canary or binaries out. That's again an issue, because even though you are working on a module which doesn't have any coordination or doesn't have any dependency, you still have to wait for the entire development. So if you take that as one app, the entire scenario which I showed you, one app, the app actually has, first of all, the monolithic apps has an issue that it requires large resources per instance. I mean, basically, you need to put these heavy apps into a single machine. You can't divide them because they are not built into services. They are a single app, you have to put them nearby. The second one, these are hard to scale. And the biggest problem I see, because I've been working with a lot of developers, the biggest problem I see is it's very, very hard for the teams to coordinate with each other to build these monolithic apps. And yes, you always have issues with SLOs around performance and availability, all that comes into the forefront. Now, how are we going to solve this? Microservices and containers. The next version, the next level of what we are doing is, can we modularize this? For example, you have a complete app, if you can break down into comparatively small services which can be managed, where every development team would focus on a service by itself. That would create much more frictionless environment to code. So microservices are essentially taking the entire app, managing them into comparatively small services where development team can focus on. The best part of this kind of architecture is you can scale them or the services as per your requirements. You don't need to scale the entire app. So for example, one piece of the service which actually is wanted to scale, for example, in an e-commerce website, if you have huge number of orders coming in, which module do you think has to scale? Order management or order processing engine. Rest of them has to be, it's okay. You don't need to scale them as big as possible. So this gives you independently scalable model, which is a really lucrative feature. Now, the problem, now coming to where you can deploy these services. Now we established that yes, microservices are going to be the future, but where do you wanted to put these microservices? again, there are issues. We started with shared machines. Shared machines as in you don't have a virtualization layer. It's just a machine with kernel, libraries, and apps installed on it. So the issues with shared machines is there is no isolation as such. There is no namespacing, but you do have common libraries. The biggest issue is they're highly coupled apps with OS. They're tightly bundled. So this works. It is not like this doesn't work. But let's think about the scaling part of these shared machines. It's very, very difficult to actually scale them up. So then came virtual machines era, where what we tried to do is we took the same applications, virtualized them, but the key challenge in virtualization or virtual machines is you still have kernel attached to libraries and the app, which makes them heavy. So how much time you take to create a virtual machine? It's not easy. I mean, it's still today, it's a heavy lifting job, even though you have the best servers or the processing engines available. So, which means you got some perks, like you got some isolation, but it is still inefficient and hard to manage as usual. Now, that's where came containers, where the kernel is taken out, the libraries and app are moduled into a single entity, and you just run them. The best thing of this architecture is the apps and the libraries are easy to scale, basically, and easy to create. It takes a fraction of a second, and easy to scale. So it just covers all your issues. So first of all, if you change your architecture, your monolithic architecture to containers, you have a container which actually can scale. Now let's talk about what we have been doing. Let's go to history. So for last 15 years, in Google, we are creating a lot of powerful infrastructure. It's been like 15 years we started building this company. And yes, we are kind of a startup of our own. So what we have to do is create our own hardware, essentially assemble them, get the best hardware engineers, and we build the best and powerful world's fastest powerful infrastructure in the world. Now, I wanted to give you some background. How do you think we are actually creating this, or what is that we are running them in this hardware? It's containers. We actually run all our services on containers. So if you look at the search, Gmail, Maps, YouTube, and Chrome, all are enabled on these data centers using containers. So this is a kind of a slide which gives you a technical innovation we are bringing to table. How many of you know these names as such? How many of them you recognize the names? Quite a lot. Yes, that's great. So these are, for people who doesn't know, these are actually white papers which Google created. You can just go ahead and Google them. These are white papers which Google released which spanned upon the open source implementations and later period of time. So we are, kind of pushing the boundaries in terms of managing the huge data. By the end of that, the entire infrastructure is built on the microservices architecture. To give you a perspective, there is a white paper called Borg. If you look at it, there is a white paper called Borg, which is our implementation of container engine. Now, how to orchestrate these containers. So Borg is there for 10 years before even the Docker exists. And this is the way we used to run. And we started running, today we create 2 billion containers every week, and it is growing. Now, how we can achieve that is essentially, basically all this. I'll show you an architectural diagram of how the Borg looks like, and how we, a simple command actually can translate into a working piece of code there. So let's establish why we need containers here. First of all, they are fast, they're portable, and they're quite efficient, and they can run anywhere in the environments. This takes away the concept of deployment hell. The concept of deployment hell means, I'll give you a backstory. For example, if you remember a ship company where it wanted to transport huge number of goods from one place to another, it has to pack those goods according to how they are created and how they have to be packed, right? So that's the biggest issue, because they create that, and they actually transport that, the packaging has to be aligned with the goods. Now, there came, if you remember the latest shipping dockyard, you will see everywhere a block, which is a container. So this container allows you to put any sort of, you can manage any sort of goods in that, close them, give it to the shipyard, they will transport it. They have a common mechanism to transport it. So the same isolation, just take the same analogy, put it into your code. You, as a developer, pack your code, put it into a container, give to the DevOps guy, where they will actually manage it on any virtual machine, or any infrastructure, or any hardware. That reduces friction between a developer and a DevOps person who want to deploy, as well as a developer who has complete control on how to pack his code without that getting changed over a period of time. So these are the beauties, or these are the best advantages you get out of the containers. So, but do you think everything is green with the container? No. There are some always limitations for this. The biggest limitation is, how do you deal with multiple servers? There are a huge number of servers where these containers or clusters has to be maintained. How do you deal with multiple servers? What if a server fails? Or what if the container fails? Or how do you define what a container failure is? So essentially, you keep on scaling it up. The container itself will become messy. You can't scale them up, or what if they fail, or what if the entire cluster fail, or how do you scale up on a cluster? So these are some of the challenges always comes with when you're using containers. Now the solution for that is manage the containers. Now how do you manage it? It's very difficult. So let's create a program which can manage the container, is what essentially is container orchestration engine, which boils down to Kubernetes. Kubernetes is something which can orchestrate the entire suite of containers. So Kubernetes and Kubernetes engine essentially are two facets. Kubernetes is essentially you can run in your laptop. It's a 100% open source framework which you can do. Whereas Kubernetes engine is a managed service. So essentially, you don't need to worry about the master node. I'll explain what the master node means. So look at these two analogies. One is maintained and managed by Google. Second one, you can run off your own by managing the entire cluster of your own. So if you go back to the history, this is the precursor of Borg. This is the white paper of entire cluster management engine. So if you look at this white paper, it was very clearly written, the architecture of Borg. So let's imagine this is the data center, and you wanted to have thousands of applications running here. How do you you just, as a developer, you wanted to deploy a Hello World application in this data center, where that application or that particular microservice will use 100 MB of memory and 1/10 of a CPU. So the way we started writing this kind of deployments is using simple code. So this piece of code will tell Borg master node, hey, master node, go ahead and deploy 10,000, whatever the number we give, deploy these many instances of microservices on the cluster of data center, where it has to use the RAM of 10 MB and disk 100 MB, disk size of whatever we have, and CPU of 0, which is 1/10 of CPU. Submit this to the master, it will directly go ahead and create it. It's so easy. So you don't need to worry about how you have to manage the entire data center there. So this is how the architecture looks like. A binary is a piece of code which your application is built on. You take the binary, you have a configuration file which talks about the binary, which is sent to a repository. Now the same binary will be given to the Borg master. The Borg master will take the binary and deploy that into the nodes. Every node here, the bottom 4 pieces which are represented here, every node is a same OS, same Linux OS. And every node has a Borglet, which is a kind of program which can listen to the Borg master. So you have suite of machines down, deployed by, which has boglets installed on it. The boglets will take care of listening to the master, where it can deploy the nodes and start running them. So this is how we were able to achieve the same small piece of code which I showed you in the earlier slide, this slide, which we have passed on to the Bog master, will start deploying n number of microservices directly. Now, once it happens, the Bog master starts creating Hello World application all over data center. You don't need to worry about scaling it up. You just need to tell the configuration, what size it has to be used, push it across. As simple as that. Now, where Kubernetes comes here is, Kubernetes is kind of a container orchestration engine which supports multiple clouds. And it is inspired by, it's direct derivative of the Borg, which I just showed you. So the Borg, which is used by Google, the same, I'll show you an analogy, the same actually, the architecture is taken out and created as a Kubernetes. It's completely open source. It is donated to open source community. So the end goal of Kubernetes is don't manage your applications, don't manage your machines, manage your applications well. So Cloud Native Computing Foundation, essentially, you can't run entire containers individually. You have to orchestrate, you have to monitor them, you have to distribute them. So there are so many open source projects which are formed under Cloud Native Computing Foundation, CNCF, where Google donated Kubernetes as one of the projects to it, which is part of orchestration. So right now, the Kubernetes is in 1.8. The stable version is 1.8. It has 4,500 plus contributors and about 3,000 GitHub stars in it. And there are a huge number of contributors to it. So essentially, which boils down to a point that if you are using or if you are building your apps on Kubernetes, there is a high chance that the same app can be run on a multi-cloud environment, be it on anywhere. So that's the added advantage you get out of it. So 10,000 view food, basically, if you look at Kubernetes on a very high level as an end user, this is how it looks like. You have a master node. Users are you people who are going to talk to the master node, developers. And the nodes are essentially machines. So if you look at the machines, every machine is installed with Kubelet, which is a service designed to talk to the master node. And the users can talk to the master node using either API call or a CLI command line. CLI actually again calls API behind the lines. And user interface. You can build your own user interface using the APIs and can actually go ahead and call with that. So if you look at the 4 pieces in the master node, etcd is kind of a database, CoreOS database, where it can store the content. So state of the nodes which are available, schedulers, which schedule the desired state configuration, and controllers actually. So now let's come to Kubernetes, how the same model of Borg translated to Kubernetes looks like. You take the Docker image, you build your application as a container, which is a Docker image, push it into Docker private GitHub repository, and push a configuration file to the master node. The configuration file is written in YAML. So everything in Kubernetes is declarative. Just submit a YAML file. It will understand how to reorganize. The Kubernetes master node will figure out a way to do rest of the work for you. So the master node, the YAML file is parsed and taken care. And then, according to the YAML file which was submitted, the individual services will be pushed across. Again, those services are taken away from the GitHub private repository you have. So the declaration happens on the top of it, where the configuration file, which is a YAML file. Once the declaration is made and pushed to master node, the master node, with the help of scheduler, actually go ahead and pushes the services into different machines, which are hard machines, which are virtual machines, and keeps on running them. So as an end user, all you just need to care about is you make an API call. An API call is just an API call, or a CLI command line, anything. Just make an API call to the Kubernetes engine or Kubernetes cluster. It just works. So all you just need to is understand how many command lines you have and keep on trying them and creating a machine of your own. So before I go into deployment sets and deployments and replica sets, let me give you a background on the smallest commodity in Kubernetes. The smallest commodity in Kubernetes is called pod. So what's a pod? Essentially, if you look at, you are the end user, that's a Kubernetes master node, which is going to create or orchestrate pods. So you don't need to create pods yourself. Pods are created using replica sets. So a replica set is essentially what creates the pods, which are individual units. Pods comprises of multiple containers. So just to make sure you understand, the containers are the smallest pieces, which runs a smaller service. Pods encapsulate the encapsulates the containers, one or multiple containers. The same pod, the replication set will actually create pods, and there will be deployments which actually creates replication sets. Your job is to create a template which hierarchizes all these facts and send using a command like kubectl create and send it so that the deployment will be created. So if I send a kubectl command which is create with the name of my name app, the deployment template looks like this. It just keeps on like replica sets of 3 and my name as application name as my app with a version v1. It just creates 3 services or 3 instances, which is a desired state configuration of the version v1 application of my app. What if I change the replicas to 4? It just create 1 more. So all you just need to is focus on the YAML template, update it, send it to Kubernetes. It will take care of replicating that. What if I kill one of them? If I have 3 services, what if I kill one of them? It just maintains the state. So any hardware failure, any service level failure is already taken care. Now you wanted to upgrade this. You wanted to upgrade the v1 of app to v2 version. You just need to have an upgrade command which actually starts creating, you have to create another replica set which is v2, which slowly kills the v1 and starts upgrading that to v2. So you have an in-place upgrades where without downtime, your application is moved to version 2. The individual services will get upgraded. Now, if you look at the pods are mortal. Every pod, which is an individual unit of container, is mortal. They die. They are bound to die, by the way. Now, how do you give an IP address to these pods? So how do you manage them? How do you communicate them? The services are essentially provides a stable IP address and DNS name resolutions to pods. So these services will essentially help you to communicate between 2 or 3 different pods, internal communication. And they also can be used for actually having them communicate to the external users. So each microservices can be individually scaled. This is how the end diagram looks like. If a simple monolithic app can be converted into different services, which are containers, and a service between them will be used to communicate or route traffic between the services there. So essentially, the right architecture is the Kubernetes will help you to schedule or orchestrate the containers. Containers are easy deployment services, and microservices actually take your monolithic app, break down that into pieces so that it can be very well managed. Now, I'll show you the exact look of what a Kubernetes engine looks like. The same Kubernetes service which you deploy on your local machine, if you take them, so Google has its own managed container engine, which is called Google Kubernetes Engine, which has all these all these features built into it. So we essentially have our OS built for containers. The Linux is developed and optimized for containers. You get a private GitHub repository. You get a fully managed service. It's a fully managed service. And you have a Docker image support. Other than that, the best way to create is go to Google Cloud Platform, go to Kubernetes Engine, go to the cluster, create a cluster, and just key in your details, select your, wherever you wanted to deploy this cluster, and what is the machine type you need. You can customize your machine types. So maybe you can select, I want 32 cores and 160 GB of RAM, and I want maybe 7, whatever the size you want. So a single click of this cluster or this service will create you a cluster size of 7, which we entered there. And every virtual machine has 32 core and 165 GB RAM overall, and it creates a cluster of its own where the master node is managed by Google Cloud. So you don't need to worry about what if the master node goes down. The master node is managed, and the cluster comes in. There is also a concept called federation, which means if you federate, you container federation where you can have this, you can have almost all the clouds connected using, you can deploy your microservices in every cloud using just Kubernetes. Yeah, so I think we are just in time. So in a nutshell, Kubernetes Engine will actually provide you a cluster in seconds. It's a fully configured cluster, a fine-grained control over the cluster, designed for multi-cloud, as well as you can actually use 5 nodes with no additional cost for that. There is a free tier available to it. So anyone who wanted or interested to practice, go to the Code Labs, just search for cloud, and search for Kubernetes in this, where you get a step-by-step approach of how to create a container engine, like basically an application in few clicks. The entire process is actually given here with screenshots. Just go ahead and try this. You will see how easy it is to create an entire microservice architecture service on Google Container Engine in a very short period of time. And thanks for coming here. And I'll be there around. If you have any questions, feel free to talk to me. Thank you.
Hey everybody, I'm Wesley. I'm happy to be here to talk to you guys. Oh, first I should say, namaskara. Welcome to our session. We're getting close to the end of the day. How are you guys doing so far? You guys learning a lot? Awesome, all right. I have to take a picture because I have to prove to my boss I actually came here and talked to you guys. Otherwise, they're not gonna pay me. Smile, everybody look like you're happy. Awesome. All right, so the first thing I want to tell you guys is this is just a big bait and switch. Quick show of hands. How many of you guys have ever heard of Google Apps Script? Hey, that's actually pretty good. Normally it's like 1 out of 10, 3 out of 10, but this was almost 4 out of 10. All right, so that's great. Well, too bad for the rest of you because that's what today's talk is all about. However, one side effect is that you'll also learn how to extend Google Docs, Sheets, Slides, Forms, and Gmail with add-ons. All right? By the way, we have 30 minutes, and I have 48 slides, so let's go. All right, and by the way, if you guys if you have any extra questions, feel free to drop them in the doc, and otherwise we can talk to you afterwards. All right? So cool. Let's go. So my main goal is to help you become successful using our developer tools and APIs. Okay, some of you guys may know that I'm the host of the G Suite Dev Show on YouTube, so I have videos from time to time, and a lot of the code samples that I'm going to show you today, there actually will be video, so you can actually watch individual video on a specific example that is interesting to you. Okay, and I'm also a contributor to the blog and also the Twitter handle. So anyway, so I look forward to keeping in touch with you guys online, even if I'm not physically here. Okay. So my background is I'm a software engineer. I was one of the original engineers that built Yahoo Mail, if you guys ever heard of that, but many, many years ago. I'm a teacher as well, too, and I'm very happy to be talking to you guys today about AppScript as well as add-ons. Okay, so this is the story. We're going to talk a little bit about AppScript, and I'll show you what kind of things you can do to automate and extend G Suite, and then I'll go more specifically into looking at add-ons, and then I'll talk about various use cases and apps that people have already done. All right, so what is Google Apps Script, and what is it not? Okay, is it another Google secret? We have lots of secrets, right? Well, you know, it's not really our best kept secret, nor is it really a secret at all. But I think it still has relatively low mindshare. That's why I asked you guys a show of hands to see who of you have heard of it before. Okay. So what is Google Apps Script? By the way, here are our original and our new logos. And the new design hints that AppScript is like a Swiss Army knife. It's very utilitarian. It's a tool based on JavaScript, but it's less like using APIs and more like using services or built-in API access. And because of that, you don't have to worry about more mundane things like writing OAuth code. Okay, so to help with this understanding, let's talk a little bit now about what AppScript is not. Okay, it's not something completely different. It's just JavaScript. So there isn't that much new to learn. Even a Python guy like me knows some JavaScript, okay? But it's also not your daddy's JavaScript, meaning it's not client-side, and it doesn't run in the browser necessarily. You're not going to use it for DOM manipulation, nor form validation. Okay, there are some exceptions, of course, but what are you going to do with the browser? Well, the only thing you're going to do with the browser is edit your source code in it. Okay, so that's generally the case with AppScript. Now, if you're familiar with Node, it's like Node because it is server-side. However, you're not running asynchronous event-driven code that execute on Node servers. Instead, your applications are going to run in the same Google data centers that powers Search and YouTube and Gmail and all the other Google services that you guys are used to using. Okay, so your apps will be running on the same machines. In fact, that will give you access to resources that you can't get with a regular Node server, right? Being able to talk to your Google Apps, access the data and things like that. So that's really where the power comes in. Okay? So if someone was to ask you, or ask me, in one sentence, how can you describe what AppScript is? Well, AppScript is a serverless JavaScript runtime for G Suite automation, extension, and integration. Okay, and then we'll look at examples of each of these so you can see what I mean by that. Okay, what kind of things can you do with AppScript? It could be something very simple, like a function in a spreadsheet. Or it could be a complete web app that does lots of different things, many, many lines of code. And, of course, everything in between. All right, now let's look at automating and extending G Suite. So we'll give you some examples, and then we'll talk about add-ons. All right, so for the Google services that you guys see on the screen here, you'll see, yes, there are some Google Apps and G Suite ones, but then there's also ones that are not part of apps or G Suite, right? Like Google Maps and YouTube. They are Google services, but they're not part of G Suite. So this gives you a hint as to the fact that AppScript can do a lot more than just deal with apps and G Suite. Okay, there's plenty more it can do. So for every Google service that you see, each one is a single JavaScript class. All right, so you see I've highlighted a couple of them here. One is for Google Calendar, one is for Google Docs. But in general, whenever you see something with app after it, that generally indicates this is a service. Notice again, it's not like using an API as much. Instead, it's kind of like an object that's already there. So the example from the page in the Docs is for Google Slides, all right, where you can open a presentation or you can create a new presentation. So it uses Slides app. All right, so that's how you access Google services. You have sort of like one JavaScript class, and then from that class, you have a whole bunch of methods that you can call to access those particular document types or those services. All right, everybody good so far? All right, good. So what is the list of all the things that you can do with AppScript? Well, all the G Suite and app stuff that you know on the left-hand side, including ones that you probably don't know. All right, but then you can also talk to these other Google services in the middle column. And then finally, we don't want to constrain you, right? Maybe you need to leave Google, right? You need to access services that are available online somewhere else, somewhere in your data center, something that belongs to your company. Or maybe it's a public service, right? So that's why we have URL fetch. So you can send HTTP GET requests as well as POST requests and talk to other apps that are online. You're not restricted to just doing everything from within a G Suite environment or a Google environment. And then similarly, if you want to talk to an external database, you can use a JDBC service. All right, so there's plenty more that you can do. All right, now what kinds of app scripts are there? Well, there's three general types. We have standalone scripts, which are exactly what they sound like. They're just regular code that sits out there and runs and does stuff for you. Then we also have add-ons and document-bound scripts. Okay, the way you get access to those is generally if you're in an editor, you pull down the Tools menu bar, and then there's a selection called Script Editor. And then from there, you'll be able to pull up the code editor for that particular, for apps scripts that you write for that particular document. Okay, and then add-ons, you can get and manage add-ons also from that pull down. And then finally, the last type of app script are the simple web apps and gadgets that run under Google Sites. Okay, so these are the three main types. Of course, in this talk, because you guys are here, we're really focused on add-ons and document-bound scripts. So I'm not going to talk about the other two anymore and just focused on the topic at hand. Okay, so document-bound scripts. Like I said, you open up Google Docs or Sheets, and then you just pull down Tools and then Script Editor. Okay, so document-bound scripts are those that are tied to specific documents, like a doc, sheet, slide, or a form. And of course, you're going to have method calls that are unique to those document types. You can only call getActiveCell for a spreadsheet because it doesn't make sense to do that for docs or things like that, right? Same thing goes for create presentation. That only works for slides. You can't create a presentation in spreadsheet and things like that, okay? So those are document-bound. Now, add-ons are a specific type of document-bound script. And then Gmail is a little bit special because Gmail add-ons are not tied to documents, but instead they're tied to individual email threads. Okay? So what are add-ons again? They allow you to extend the existing functionality of G Suite applications or allows you to embed the functionality in your app inside ours, all right? Giving your users that access where, oh gosh, I don't have to exit my editor to go access this app. I don't have to switch browser tabs. I can actually get the functionality from your app directly inside one of Google's editors or Gmail. Okay? So the add-ons that we have launched in 2014 for Google Docs, Sheets, and Forms. And then just 9 weeks ago, we released Google Slides add-ons. And then just 5 weeks ago, we released Gmail add-ons. So this is pretty new stuff. So I'm going to have like more examples for the last two just because of the latest hotness. All right, but I'm also going to show you some examples of the other types too, just so you can see the variety of things that you can do. Okay? All right, so let's say you're new to AppScript. I'm happy that many of you guys raise your hands, but let's get everybody else up to speed. Okay, so when you create a brand new AppScript project, you get this little panel that you see here that gives you some predefined code, some boilerplate code in case you're writing those specific types of add-ons. If not, just choose blank project. That's what I usually pick because I just want a blank slate and I just want to start something from scratch. Okay, so that's the first experience that you have. And then once you get past this, then you get dropped into the editor. And so your first Hello World application will look something like this. Okay, so I'm in a spreadsheet. I pull down Tools, Script Editor, blank project, and then I'm going to type in this one-line JavaScript function, okay, which I split up into 4 lines so you can actually see each piece one at a time. All right, but I have a generic function. It connects to the spreadsheet. And what are the commands I want it to do? I want it to get the current active sheet that I'm on as if I was sitting in front of the user interface and looking at that spreadsheet in my computer. I want to access what is in cell A1 in the upper left-hand corner, and then what do I want to do with that cell? I want to set the value of that cell to Hello World. Okay, so once you save this and run it, notice there's no authorization code. However, when you run the script, guess what? Your users still have to give permission to your apps to be able to access their spreadsheet because it's their personal data, right? So they still have to go through the authorization process. But you didn't have to write any OAuth code because that part is built in already. Okay, so that's one of the useful things about using AppScript is that it's more user-friendly or developer-friendly. If you were to use our REST APIs, you would actually have to write OAuth code to manage getting of an access token in order to be able to access user data. Okay, so this is definitely one of the benefits for developers is that they don't have to worry about the OAuth. And then once the user clicks allow, giving permission for your code to access their spreadsheet, then you're going to expect that that text is going to show up in the spreadsheet. Okay? It's almost like magic. When it happens the very first time, it'll make you smile. All right? And that's the best part about it is that you feel that you've gotten something done. And now your mind is going to wonder as to, well, if I can do this, think of all the other things that I could build with it, right? It's really, really exciting. All right? So if you want to review this simple Hello World, of course, I have a video. It's what I do for a living. I don't have a private life anymore. Okay? So I'm here to make you guys successful. So that's my job. All right, now let's look at this one. What can we do with this? That's an address, right? Happens to be the address of the Google New York office, but maybe you want to invite your friend here for lunch. What can you do with it? Well, we know we can talk to a spreadsheet, but remember, the universe is pretty big from within Google. I can talk to other Google services too, right? So for example, I could say, hey, you know what? I'm going to talk to that spreadsheet again, the current active sheet that I'm on. And this time I want to look at cell A2, which we can see is the actual address, right? So what do we want to do with A2? Well, we're going to get its value, save that address, and then I could say, hey, Google Maps, can you create me a brand new map and put a pin on that address? Cool, right? And then furthermore, maybe you want your friend to come to lunch here, at the Google office, right? So I can then say, hey, Gmail, can you send a link to this map to my friend so that they know where to come for lunch? Okay? And that's it. You've got a 4-line JavaScript application, 4 lines, but it touches 3 different Google products: Spreadsheets, Google Sheets, Google Maps, and Gmail, right? I mean, it's not exactly a mission-critical app, right? But it does show you that you can use multiple Google services simultaneously to write tools that are somewhat useful or could be very useful, okay? And of course, there's a video in case you want to review this too. But once you can do something like this, where can you take this? Well, guess what? Maybe you're a salesperson. Maybe you have to visit all of your customers in the New York area. All right, well, guess what? I don't have to have just one address. I could have 4 addresses for all my customers. Then I can kind of plan out where, which way I want to go. And then guess what? I have access to Google Maps driving directions too. So if I have to drive, or if I have to bike or walk, I can get that stuff programmatically as well too. And maybe you have a monthly book club. Maybe it meets at a different location every month. Maybe you want to tell everybody, hey, this month we're meeting at this location. Okay? Or maybe I have a user group that meets once a month in a different location, right? So you can kind of like imagine what kind of things you can build with just a little bit more code than the example that I showed you guys. Okay? In fact, one of the other things that you can do is maybe you can ask your membership, so who's coming, right? Maybe you have a Google form, and then as soon as they submit the form, maybe then they're coming, and then you can email them the link to the map of the location. Because why bother mailing all 400 people when you only know that 200 are coming, right? You don't want to spam everybody, so that's like another use case, another way to extend this particular type of application. Okay? All right. Let's say I have a bunch of images. For brevity's sake, let's just pretend they're all online, but they could also be somewhere else. You could have a zip file of images. You could have a Google Drive folder full of images. Okay, but for this example, let's just pretend I've got these 4 images that are online, and I want to build a slide deck with these images. Okay, so you can do that using the slide service that we just launched 9 weeks ago. All right, so taking each one of these images and then building an individual slide for each one. So you can actually see that in the presentation that it's been created based on the images that you see on the left-hand side. So how do we do something like this? How complicated is this code? Okay, it's not that complicated. In fact, I would say this is only about 6, 7 lines of code. If you don't count the data, because I have a whole list of the images and the URLs, but if you don't consider those lines of code, well, we really only have our main body has 4 lines of code here, all right? And I'm just going to walk you through each line really quickly right now so you can get an idea of what it does. But everybody knows that when you guys create a new Google slide deck, you get the title page, right? It's got a title and a subtitle. So the whole purpose of the first 3 lines of code is to fill in the name of the presentation, which comes in the name variable, and then this subtitle down here, which is Google Apps Script Slide Service Demo. So all the first 3 lines do is fill in the title and the subtitle on the title slide. Okay? It's the same thing as you see here. There's the title, there's a subtitle. All the other ones are added. Okay? So once we have that, then we have a for loop, all right, that loops through all of the images in the array, all right, and for every image, it calls the add image slide function, and all that does is adds a blank slide and inserts that image into that slide. And that's it. Now you have a slideshow. Okay? And not too many lines of code. And of course, there's a video. Okay, so that's one example. Now, so what we've seen so far are document-bound scripts. We had the hello world, we had the maps and the Gmail example. Right? Those are tied to a Google Sheet. They are document-bound to a Google Sheet. And then we just looked at the creating of a slideshow. That's tied to a Google Slides presentation. Now, how do we convert those document-bound scripts into add-ons, right? Because that's really the whole purpose of this talk, right? So, and why would you convert something to an add-on? One of the main reasons is it's really hard to share that code, all right? You'd have to cut and paste it or somehow copy the document. That's really not distributable, right? If you turn things into an add-on and put it into the G Suite Marketplace or the Chrome Web Store, then other users can find your app and install it, perhaps for their entire companies. Okay? So you can actually make a living writing software to help companies be more efficient. All right? And so one of the things that you have to do to convert a bound script to an add-on are a couple of things. One is what happens when this document is opened. All right? So you have to add an on-open. What happens when this add-on is installed? You need an on-install. Generally, it just calls on-open. All right? And then, if you want to further modify the user interface, okay, you can do that. You can add a sidebar so that your users can see your app on the right-hand side within the same document, or the same spreadsheet, or the same form. Okay? So those are the key things that you would need to implement on top of the existing code. So everything else on the bottom there is whatever we had before. So all the code I showed you before, the hello world, the Gmail and the Google Maps example, and then creating of slides, those things are part of the document bound script. All you would do is add these things, okay? And then the other thing that you need to really be careful about is you need to really understand the authorization lifecycle. And the reason for this is because companies may be installing your code, right? So it would make people nervous if all of a sudden when they open their document, there's this weird add-on that was added to their, to their document, right? So there's a slightly more complex authorization lifecycle that you need to understand, because what happens is when that add-on first runs, it doesn't have full permission to do everything. Okay, you have to wait for the user to sort of like opt in to be using this particular add-on. Okay, just because it's installed doesn't mean that it's been enabled for usage. So if you are going to be creating lots of add-ons, just learn the life cycle well so you understand what things your script can and cannot do and at which times. All right, so that's pretty important to know. But once you get past that, then you'll have an add-on, and you can upload it to the G Suite Marketplace or the Chrome Web Store, and people can find it. You make a logo, you make a description, entice your users. Why should people install your add-on? Why is it useful? You have to keep those things in mind. So even though you're developers, part of your brain has to sometimes think, what do I do marketing-wise? How do I get people interested in my add-on? And to encourage them to install it, and how can I make their lives easier? Okay, so that's really the main thing. Now, let's talk about Gmail add-ons now, because Gmail add-ons are a little bit different. So let's say that your company sent you here for work, okay? Maybe you booked an airline reservation, maybe you have a hotel reservation, and then maybe you're catching Ola taxis every day, or Uber or whatnot, okay? So we all know that these email receipts are coming into our Gmail because we see them as they happen, right? And if we're going to have to create an expense report and get reimbursed by our companies, it's kind of a burden to have to look through all my receipts, copy down the information, go to my separate expense reporting app, fill in all that information, and then submit it to get reimbursed, right? Can't we just do the same thing without leaving Gmail? Can't I just process my expenses at the same time I'm looking at the receipt? And can't I do it on the web and mobile without having to write two separate apps for this, right? So those are the key questions that drove the product team to creating Gmail add-ons for everyone, okay? So I'm happy to say that we can actually do this now. So you can actually make this little form show up right in your Gmail. In fact, I just hid it so that you didn't see it before. But this is exactly what it would look like if you were on your computer and you actually brought up this particular add-on that my summer intern wrote this summer, or this past summer, where it could read the contents out of your email message, specifically the receipt, right? It can pull out the date of the transaction, the amount of the transaction, and a description. All you really need to provide is a spreadsheet URL, and when you click submit, okay? Oh, by the way, it would be great if I could do it on mobile too, so I don't have to wait to get back to the office. I can actually do it while I'm sitting in the cab, all right? So that's the one cool thing about Gmail add-ons, is that once you write it, it will work on the web, and it will work in mobile, and you don't have to write any other version, right? Just one piece of source code. So this is the exact same receipt, but on an Android device, okay? So anyway, so once we have this and we click submit, we get the, my form has been successfully submitted, and then when you go to that spreadsheet, well, now you have one place that you can just leave it up and just do your expense report straight out from here, okay? So that's really the main reason behind this. So the code is going to be a little bit larger because Gmail provides you the ability to add your own user interface. So for us, we had that little form, right? So it takes a little bit to create the user interface and then build the code that runs behind it. Okay, so here's just one kind of quick view of building the expenses form. All right, you can see all the source code, of course, in the video, and we've also made this example available on GitHub, so you can download the entire app and study it and implement it and change it and all that kind of stuff. So everything's available for you. It's also available as the Code Lab All right, so if you really want to learn how to do Gmail add-ons, you can actually you can build this example line by line, well, maybe not line by line, but chunk by chunk. Okay, so you can actually build this app for yourself, and then you can take this as motivation to building your own Gmail add-ons. Okay, so that's called Expense It. All right, now let's talk about in general. Now that I've shown you guys the technology, what have other companies done before you? What are some of the other use cases for AppScript as well as for add-ons? Okay, so categories, something like these 6. You know, having business workflows, controlling resources, automating things that normally take a lot of effort to do as a human, building dashboards and other reporting for managers, integrating with other third-party tools, you know, because, you know, for G Suite, we can't provide everything for you. You know, we have you know, a document editor, we have a spreadsheet, we have presentations, but we don't have a CRM, we don't have, you know, payroll and HR apps, we don't have that kind of functionality. So these are the kind of things that you can bring in to your G Suite environment by using these, you know, third-party integrations. And then you can also, you know, if you are a G Suite or a Google Apps domain administrator, you can actually use this tool to automate a lot of stuff. Like, for example, if next week you have 100 new employees, you really don't want to be creating each of their Gmail accounts one at a time. That'll drive you crazy. I mean, it's good job security, but you're probably going to be burnt out pretty soon. Okay? So those are the kind of things that you can do with AppScript. All right? Teachers really, believe it or not, they like to write teacher tools to help automate you know, instructing students. So for example, there's a well-known app called Flubaroo, and what that is if a teacher creates an exam, you know, using Google Forms, and all the students submit the answers into a spreadsheet, well, guess what? The teacher can submit their own answer, which is the answer key, right? And then the Flubaroo tool can actually grade everybody else, all the students' results based on the teacher's answer key. All right? So tools like that are very, very useful. Okay? And then automation, like mail merge, right? There's so many different types of mail merges, like form letters in Google Docs. You have your email addresses in Google Sheets, and then you want to send these through Gmail. All 3 of these are possible, right? They're 3 different Google products, but they're all supported by AppScript. So automation is a big one. Enterprise workflow. So for my team, everybody is going on vacation at a different time, right? And so what happens is everybody has their own out of office in their calendars, but then we have an AppScript code that builds a team vacation calendar so that if you want to see who's in the office, you can actually take a look at this one calendar and it tells you when everybody is out of town. So that's a very useful thing too, right? All right, and then of course you can just go to the G Suite Marketplace and look at all the different apps that are available for you. And you can see how many users they have, right? I mean, your app can actually go viral if companies install it. So that's another motivation as to why you guys should consider writing add-ons. And then, you know, a big company like Lucidchart, they have a very famous web app. But you know what? They integrated that app as an add-on for slides because maybe I want to have these diagrams incorporated into my slide decks. So they built an add-on specifically for this purpose. It's pretty awesome. Okay? All right, now what else do you need to know? You may have heard about AppMaker. So if you don't code at all, right, AppMaker is a tool that you can drag and drop web components or UI components like a text box, a dialog window, and it automatically generates AppScript code underneath the covers. And so if you know AppScript, you can modify and customize your AppMaker apps. So that's pretty powerful. Okay? So anyway, so keep that in mind. You know, it's a little bit outside the scope of this talk, but overall, what I hope to impress on you this last half hour is that AppScript and add-ons are just JavaScript. It gives you access to existing Google services and other online resources. It's not like an API, so you don't have to worry about like authentication and things like that. It's more like built-in services. It's serverless. You don't have to set up VMs or anything like that. It runs in Google data centers for you. And there's lots of different use cases. You can extend G Suite with add-ons, or you can integrate your app's functionality. And then you can further customize AppMaker applications. And hopefully, after today, it's no longer our secret, all right? Because you guys all know about it now. Okay? If you want support, we have Stack Overflow. We have a Google Plus community. We have the issue tracker. Other things that you can do, we have a code lab. So come join me tomorrow. I'll show you a slide in a moment. We can do a code lab together tomorrow. There's a whole bunch of videos, some docs, and if you want to, you can also use our REST APIs. And then, like I said, come join me tomorrow. I'm doing a hands-on training. One is AppScript, the other is actually using our REST APIs. I'm also going to be talking about the Sheets API later on in the afternoon. And if you're a Python person, I'm speaking at the Bangalore Python Users Group on Sunday. So hope to see you guys more later this week. Thank you very much. If you have any questions, just I'll be just down here or outside. Or if you have extra questions that you remember or you don't remember until later, just feel free to drop something into that doc. Okay? That's it. All right, thank you guys. Take care.
Namaskara, Bengaluru. Namaste, India. Namaskara, Bengaluru. Hello. Took some practicing, and the mic wasn't working, so here I am. Thank you very much for joining up really late, or showing up really late. I'm the last talk, and the title of my talk is What's Next for the Web? Or an alternative title could be Exploring About Flags. My name is Thomas Steiner. I work as a mobile solutions consultant based out of the Google Hamburg office. I'm Tomayak on the internet. So before we get started, here's a quick warning. There's a lot of content coming, and I'm going to speak fast, probably even too fast. So hold on to your seats, and watch out for all the links. So on all slides, there's links. So take a photo, write down the links, whatever, so you can catch up afterward if you find something that is interesting. With that, let's get started on the first topic, which is progressive web apps, PWAs. And something that is really and truly immersive are obviously full-screen PWAs, because your PWA deserves a lot of screen real estate. So some of you may remember an app called paperplanes.world. It should still be up, so if you want to join on your phones, you can try that. It's a full-screen PWA. And the cool thing about it is if you pay close attention, there's something missing, which is the top bar with the Wi-Fi signal, with the clock, and so on. It's a true game, so you get a true, fully immersive, full-screen experience. How do you get that? In your web app manifest, you can now set the display property to full screen, and your app will be rendered in a full-screen view. This is not always useful, but if you write a game, if you create a game, it's definitely something that you can try out. Something else in the area of progressive web apps is they have become real applications on people's phones. With a new improved add-to-home screen flow, users will now be able to add your application directly to their home screens and find it in the app drawer. So when they search for the app, it will just show up between all the other native applications. And if you update the web app manifest, you can now also change the icon and change the name, and it will just be reflected directly on people's phones. And with the improved flow, based on the manifest scope, an Android intent filter is being created. And this filter defines when the app should be opened. So when you see this little animation here, I'm receiving a chat message, I'm clicking on the chat message, and then the application opens. The WebShare API is sharing, caring, definitely. Sharing is caring. So we should make sharing easy. In 2017, if you look at publisher sites, they commonly look like this. So you have a lot of screen real estate wasted for all the sharing buttons. And obviously, if you want to share it, always the one social network that you would actually want to share this article is missing. So that's a problem, really. And also, if you've seen before, sometimes if you have full-screen PWAs, there's not even a URL bar where you could just quickly copy the URL from. So what can we do about that? The answer is the WebShare API. The WebShare API opens the native sharing dialog directly in the Android phone. And it has a very simple API that is promise-based. You call navigator.share, then you give it a title, a text, and a URL. And then people can just share it. So you can see here, the native share dialog opens. You can select whatever networks you want to have there. It's all customizable by the user, and it will always be the same for all web pages. It's not dependent on the website. It's dependent on you as a user. Next topic is web push notifications. And luckily, now finally on macOS, not iOS, macOS, they're no longer an alien. Before, they were kind of artificially graded and had this not really native-looking feel. And now, finally, they're just integrated directly in the control and notification center, which also means they respect the do not disturb settings. So something that we really found was a pain. People set up do not disturb and then receiving all these notifications. Now they just respect the operating system's do not disturb settings. Navigation preload. This is one of the more interesting and more complex things, actually. This is about waiting for the service worker to boot. What does this mean? So if you have a PWA, it at some point needs to boot and start the service worker. And it turns out this can take some time. And actually, if you are a big site with a lot of users and a lot of views, and if you are a site that is active on many tabs, like, for example, Facebook, where you have facebook.com, obviously, but then also a ton of articles with like buttons that also tend to connect to the service worker, this is something that can really harm performance. So with the service worker navigation preload origin trial, we are trying to find an answer to that. And essentially, the idea is to parallelize a before serial task. So instead of having the service worker boot and only then intercepting navigation requests, the core idea here is to already start listening for requests while the service worker is still booting and loading. So speaking of code, how could this look like? In the service worker, during the activate event, you await until the navigation preload is enabled. So you essentially start the preloading already. And then in the fetch event, when you go through your is the response somewhere available, you can check if you maybe have a preloaded response already. So as I said, it's kind of complex really, but there's links on the slide so you can follow up after the talk. Very exciting feature. Something that is always a pain is signing into pages and signing up for pages. And we have a solution for that, which is called the OneTap Sign-Up API. So what problem does this API solve? Essentially, before, you always had this like, do I use federated login? Do I use the Google button? Do I use the Facebook button? If I use that, will it actually post that I'm using this app on Facebook, or is it, so you never quite know. Or if you use username and password, it's like, mistyped, go back, correct. Of course, you have forgotten the password, and you have to click or link the forgot password link. So this can be really painful. With the OneTap Sign-Up API, this is gone away. And the best thing is, this works on all browsers. This works on iOS, this works on desktop, Firefox, this works everywhere, essentially. So it's a new API that allows you to create accounts on the mobile web with OneTap using a Google address, and it's based on a standard called OpenYOLO. You only log in once, OpenYOLO. It also supports the automatic return user sign-in. So if you have been on the page before and you come back, you will automatically be signed in. If you're a marketer, that's something that is very valuable, because like this, you can stitch sessions together. If people are on mobile and on desktop and they use different devices, but the same login, you can then finally stitch the sessions together. So very, very useful information here. It's launched live. You can see the URL down here. On the code side, how does it work? Well, first, you need to do some setup. So there's a const with the options. We set the supported auth methods and the supported ID token providers. You can see the values here. Then you need to set up a handle result function that will, deal with the result when you get it back. And essentially, there's two cases. There's the auto sign-in, and there's the auto sign-up. Let's start with the auto sign-in. So if you have the user and the user is coming back, you can use the Google YOLO.retrieve function with the options that you have configured a little bit further up, and then you handle the result. So essentially, you very easily can sign in people who have been on your page before. If you need to sign up users, so if they are on the page for the first time, you have the Google YOLO.hint function. Again, it takes the options object from before and will then be able to handle the result as well. So the result is, of course, is the user a valid user or not? PWA always has this problem of, if you have an application and you want to store content offline, is there enough memory left? So is there enough storage left? This can be finally answered because now we have the storage estimation API. This allows you to, with just one call to the function navigator.storage.estimate, find out, after the promise fulfilled, how much memory you have left. And essentially, you can get usage information and you get quota information, so you can calculate the delta, how much memory can you still use. This can be useful if you want to decide, should I really offline store whatever big asset, yes or no, so you can dynamically decide now if you want to do that. Next big topic area is media-related APIs. The first one is the image capture API, because it allows you to zoom in on what really matters. So you can see me playing around with this API in the office. I'm zooming in on my big nose. And yeah, so how do we work? Well, essentially, it allows you to get low-level access to the phone's hardware. So if your camera has zoom, you can now access the camera zoom directly from within JavaScript. Let's have a look at how this works. So the code here is connected to this simple animation that you can see. So first, from a media stream, we get the video track. And from this video track, we get the capabilities. So what is this video track capable of doing? And once we have the track, we can get its settings. Then we have the settings. And then we get a reference to the query selector here, to the input with the query selector. And then we come to kind of initialize the input. So we need to know how far and how minimal is the zooming level. So we look at the capabilities, at the zoom, the min and the max, and set the min and the max of the input accordingly. And then we can set the value of the slider to the setting to the zoom property of the settings object. And then essentially all we do is when the slider is being moved, so when the input changes, we apply the constraints to the zoom. So really exciting. The shape detection API allows you to, in real time, detect faces, read barcodes, and even run OCR, optical character recognition, from camera input. You can see on this demo here, I'm holding my phone and I'm scanning the website of the previous DDD in Krakow. And you can see on this page there's a barcode, but there's also text, obviously, and a face. And the camera detects this live, the API detects this live, and you can see the bounding boxes that are drawn here directly on the page. Again, how does it work? Very quick, the code. You have 3 different detectors that you need to initialize: a face detector, a text detector, and a barcode detector. And because everything is promise-based, you can just use promise.all, call all the detection methods of all the different detectors, and then you get the resulting faces, texts, and barcodes back. And you can then, I don't know, draw bounding boxes or whatnot. So here you can see I'm simply logging them to the console. Very powerful API directly built into the browser. The media session API, so we stay in the area of media, allows to make your media sessions a lot more meaningful. So something you encounter and when you use the media session API is when you swipe down on an Android device, you can now see track information. You can see album information. You can see album artwork. And like this, you have the more meaningful way of controlling your media directly from the widget that you can see when you swipe down. So you can see, you can pause, you can fast forward, and so on. And there's a lot of information. So if you zoom in on what kind of information you can see, you have the title, you have the artist, you have the album, you have the artwork, and then you can connect to all the different action buttons that you have. So you can seek backward, previous track, seek forward, and next track. And of course, play and pause. So code-wise, how does that work? You pass a new media metadata object with all the different things filled out. So it looks a bit intimidating, but if you look, it's just very straightforward. Title, artist, album, artwork in different sizes and different resolutions. And then you can connect all the different action handlers to the particular events. So play, pause, seek backward, and so on. So you can really make a media player that is super powerful and directly integrated with the Android widget. The Media Capabilities API is a very interesting new API that allows you to determine not only if a certain device can play a given media file, but also if it can do so in a smooth way and in a power-efficient way. So this is very important recently because, you know, battery life on mobile devices is always a problem. So with this API, you can directly find out, well, is a particular file smoothly playable and power efficiently playable. Like this, you can dynamically decide, well, maybe the person is on 20% battery only, and in this case, you may want to ship a lower res version of a media file rather than shipping the super high res file. And also, you can dynamically decide, is this phone even able to play this file smoothly? So have a look at the code. You have the navigated media capabilities.query method here. and you pass it an object where you essentially describe what is your media file like. So you have a file, it's a video, it's using the video WebM codec, it has height and width, frame rate, bit rate, blah, blah, blah. So you can see, you simply list the properties of a video file, and then you get a result back, and in this result you can see not only is this supported at all, which is yes or no, but you can also see is the playback going to be smooth. So if you have a device that is really low power, maybe you won't be able to play back smoothly a high-res video. And also, the most important question in some cases, is it power efficient? So will the CPU be maxed out when playing, or has the CPU some bandwidth upwards for doing other things on top? Quite exciting API. Going over to WebVR, because sometimes the real reality is not real enough. WebVR allows you to create compelling VR experiences in the browser. You can see a demo here created by Martin Splitt, where you can just use your device and get a really realistic VR view of how, for example, here for an interior designer, a certain piece of furniture would look like in your room or in a simulated room here. WebVR is an open standard that makes it possible to experience VR directly in the browser. So you don't need to download any plugins, you don't need any additional software. You just point people to a URL, then they can take out their viewer, which can be Google Cardboard or whatever, and then they can see directly from their browser in their phones how something would look like. So very exciting, very amazing, and really, I think for some professions, even life-changing. If you are an interior designer, definitely have a look at this. And topic that is very dear to my heart is performance and performance-related APIs. So the first topic in there is the Network Information API. This API allows you to know how fast you can go. It actually does allow you to get meaningful real-time network information. Today, I think we all have experienced, we've been on Wi-Fi, so in theory, super fast, but in practice, well, you all know how the Wi-Fi was here. Sometimes it wasn't really the best. So with the Network Information API, we now get not only static information, like the type and the downlink back, but we also get the effective type. So today, sometimes the Wi-Fi connection would have been a Wi-Fi connection of type, but effective type would maybe have been only 2G. So this is something that is, of course, very helpful if you want to make real-time decisions, what to do with a certain file, for example, or image. I have one example where you can actually combine media queries with the Network Information API. So here, I'm using JavaScript to find out if a given device has a so-called retina display. So I'm looking at the min device pixel ratio. So I'm looking if the min device pixel ratio is 2 and if the min resolution is at least 192 dpi. So if this media query matches, I know that the device supports retina, so is a retina display. But then I dynamically take the network information into account, and only if the device supports retina and only if the navigator.connection.effective type is 4G, meaning a fast connection, only then I use retina graphics. Else, even if the media queries say that's a great device, it could support media query, could support high-res graphics, I'm not using them because the network right now doesn't permit. So that's just a quick idea what this kind of things would allow. The next thing is performance APIs, because you should care what is happening on your page and when your content loads. And here we have the navigation timing API that allows you to get general performance data. You can see here it's all available in the window.performance.timing object. And this variable, we call it perf data, then has sub properties like perf data.load event. And if you use the perf data.load event and you subtract the perf data.navigation start, you get something which is called page load time. You can see there's connect time, there's render time. So you get a lot of useful information that you can then just collect in a table and maybe report back to your analytics system. And like this, you get real-time user data of actual users out there. And you can see, well, in the lab, we're simulating this and that, but actually users in the wild are experiencing something completely different maybe. So you can get very easily real-time performance data from your users. And sometimes you also want to see how fast your page is rendered. And for this, you can get from the performance API, from the paint timing API, different events, like for example, paint events. If you initialize a performance observer, you can then check for certain paint events and see when did they happen. So you can, in the server, then observe entry types of type paint. And like this, have a look at what paint event is happening on the page. You can see how I'm doing that even after the fact on this page here. I'm just looking at performance.getEntries by type, paint, and then you can see what information I get. I get first paint, and I get first contentful paint. First paint is when is something at the first moment that something is being painted on the screen, which could be something as simple as the background color changes from white to whatever blue. And the first meaningful or first contentful paint is when can the user actually start reading the page, for example. So when is an image loaded, when is the text loaded. So something meaningful is on the screen so that the person can actually start consuming the page. And something else that is quite new are client hints. Like this, you can find out how capable a user's device is. Client hints are especially useful on low memory devices. So in the Chrome team, they've done Chrome telemetry. So they have essentially figured out by using crash reports what kind of things happened and what kind of things led to crash reports. And it turns out that out-of-memory crashes happen on a lot of low-end devices that have very limited RAM, so only 512 megabytes of RAM, or even or 1 gigabyte of RAM. And if you know that you have a low-powered device that has a little less RAM than, I don't know, mid-tier devices or high-tier devices, then you can decide dynamically to serve only a light version of your page. So servers can advertise support for client hints by using the accept-ch for client hints header, and I can list all the different the different client hints that they support, like for example, device memory. And on the client then, the client can then report back to the server and say, my device memory is 0.5, for example, so 0.5 gigabytes. And like this, dynamically, you can decide on the server, well, it's a light device, maybe I should be only serving a light version of my page. You can also access this information from JavaScript. So you have here navigator.deviceMemory, which prints 0.5. And you can also get an information about the number of cores that the CPU of the device has. Navigator.hardware concurrency. And you can see I'm having here a low-powered device with only 0.5 gigabytes and only 2 cores instead of maybe 4 or 8. New JavaScript features, because in the end, everything we do is powered by JavaScript. Something that is really amazing is dynamic module imports. They allow you to really, truly lazy load JavaScript code. So here, for example, in the code, you have a button, and it has an event listener that on click dynamically loads the code for this dialog box that the button triggers. So once the import is finished, we can then open the dialog box, for example. Or we can catch an error in case of something goes wrong. So import allows you for dynamically importing and loading JavaScript. Very exciting. We have asynchronous generator functions, because we all know dealing with asynchronous data can be really painful. And they can be used, for example, in for-off loops. And you can also create custom asynchronous iterators through asynchronous iterator factories. So you can see one example here. We have a generator function, so you can see the little star. You have a response that is awaited from a promise, so from the fetch. And then we have B, which is the body of the response. And we have this asynchronous for await const chunk of, and then a magic function that just gives us a chunk back of the file, and we can then yield the chunk's length dynamically. So really exciting new functionality that this provides. And then finally, well, no pun intended, we have the finally method in promises. Because oftentimes you need to do something in a promise, nevertheless, if the promise has fulfilled or if the promise has been rejected. So you can see here I'm fetching a display in my function here. I'm showing a loading spinner. Then I'm trying to fetch a URL. Then I get the response. Then I get the response as text. and I catch in case of something happens. And then finally, so in all cases, no matter what happened, if the then case happened or the catch case happened, I'm getting the text, which can be the error message or the actual response text, and then I'm just displaying it, and I'm hiding my loading spinner. So pretty elegant way of dealing with code without repeating yourself. And then over to hardware-related APIs. So a lot of new hardware-related APIs are available. For example, the Bluetooth API, Web Bluetooth API, that allows you to communicate with nearby Bluetooth devices. What you can see here is a demo from a colleague of mine, François Beaufort, who is using his phone to control Bluetooth candles. So just from a website, and he's sending messages over to the Bluetooth candles. Like this, the Web Bluetooth API allows you to discover and communicate with devices that are nearby. It's using the Bluetooth 4 wireless standard via the generic attribute profile GET. This is already implemented in a number of browsers, and you can definitely play around with it on Chrome, Android, Linux, macOS, and Chrome OS. Relatively similar, Web USB, where you expose USB devices and make them accessible from the web. In this demo by Kenneth Rode Christiansen, you can see how he is playing with Web USB and sending a message to a dot matrix display from a website. So he's typing in on the website some message, Web USB rocks. He's sending it to the device via Web USB, and then it's being displayed on the dot matrix display. This allows you to, well, deal with specifically designed for web USB devices. And obviously, this is a very powerful API, so it has to be HTTPS only. And again, it's implemented in a number of browsers: Chrome, Android, Linux, macOS, and in Chrome OS as well. But definitely, this is not the end. This is just the beginning. So if you want to stay up to date, definitely subscribe to developers.google.com/web/updates. And don't clap quite yet, because this is not the end, really. We have one big surprise. We have one next big thing. And this thing is actually a person. And this person has dug very deeply to find the craziest of things web. Please welcome Jake for the big web quiz. And with that, thank you very much for listening.
Nice work. Okay, everyone. This is the last session of the day. It's a short one. It's only 10 minutes long, so I'm not going to get between you and the after party for too long. But what we're going to do now is we're going to play a game. We are going to play. There should be some sound playing, if someone can make that happen. There we go. We're going to play the Big Web Quiz. So on your tablets, on your phones, on your laptops, whatever you've got that still has some power remaining, get yourself down to bigwebquiz.com, and there's a button there to sign in with a Google account, so you can just press that. And yes, it's going to be a quiz about all of the sort of weirdest, strangest corners of the web platform. But if you're someone here who doesn't code on the web, then I recommend playing along anyway, because even if you're just guessing randomly, you might beat your colleagues who are web experts, so that'll be a fun thing to embarrass them with. So as a speaker, you get asked a few questions like a few hours before a talk, usually things like, do you have your laptop? What kind of laptop is it? What are your slides built in? I was asked, are you allergic to bees? Which surprised me, but apparently, I don't know if you saw the talks earlier on this stage, apparently there was a big swarm of bees attacking the speakers, and I've just been petrified for the last 2 hours thinking like, my talk's going to be just me being attacked by this absolute swarm of animals trying to get me, but apparently that's, it's not going to be that bad. Is logging on going okay? Do we have enough Wi-Fi? People are logging in? Excellent, that's a good sign. Okay, so we're going to try and do the first question. Device is ready. Here we go. Which of the following are valid CSS colors? So we have 4 here. Select all of the ones that you think are valid and hit submit. So we have light goldenrod yellow, blanched almond, Chuck Norris, and Peru. Select all the ones you think are valid CSS colors and hit submit. The question should be on your phones now. what this display is, this is a live result of your answers coming through. So we can see from this that 63% of you are pretty confident on one of those answers. There's one of them here, 20% you're not so sure about. So these are the ones coming in live. I'm going to close the question in a few seconds, so just take a guess if you haven't already. Just make sure you hit the submit button. These are good lights. Thank you, whoever's doing that. Okay, get that answer in if you haven't already. 3, 2, 1. I'm closing the question. All right, so let's see what your answers are. Okay, so we're pretty confident about blanched almond and light goldenrod yellow. Not so sure about Peru and Chuck Norris, though. But the correct answers, it's all of them, except for Chuck Norris. But Chuck Norris does have some history when it comes to colors on the web. Chuck Norris is actually a valid HTML color. This will work. This will display a sort of dark red color. And the reason for it is that HTML, it will take the Chuck Norris, it will zero out anything that's not a valid hex number. It will split them into 3, it will treat those as RGB, and then for each of the parts, it will truncate it to 2 characters each, and from that you get a color. As you see, it's a dark red. But that does not work in CSS. Okay, let's move on to our next question. Devices at the ready, here we go. Okay. Which of the following will render? And by render, I mean which will the user be able to see with their eyes. So we have a div here, visibility hidden, it says hello. And inside it, we have a div with visibility visible, and it says world. We have a div here with opacity 0, foo, and inside it, a div with opacity 1, bar. Get your answers in, select all that apply. Make sure you hit that submit button as well. Okay, so we're pretty confident that one of them is going to render. We're sort of hovering around the 50% mark. Big confidence here for one of them, sort of around the 65, 70% mark. So low confidence for one of them, 20%. It'll be interesting to see which one that is. Get your answers in if you haven't already. I'm closing the question in 3, 2, 1, and it's closed. So what are we thinking? Okay, pretty confident on bar and world, less confident on hello and foo. The answers, just world will render. Okay, but it will render, and here's why. So when you're dealing with opacity, it's very much like layers in Photoshop. So if you give something an opacity of 0.5, then it fades the whole thing as if it were a layer. And if you give something inside at opacity 1, there's no change there, because the whole layer is at 0.5. The things inside it are already at 1. Whereas visibility hidden is actually different. So we can give something visibility hidden, but we can give things inside it visibility visible, and it will sort of bring them back into rendering. And this is actually really useful if you're paint profiling, because you can hide everything on the page except one element and just measure how much processor time that's taking. Okay, next question. Devices at the ready. Here we go. What is the final value of this div's class attributes? So we've got a div here, it's got a class equals A and class equals B, but what is the final value that the browser decides? Is it A, B, AB together, or A space B? Select the one that applies. So we can see as a room, there's one answer that you're pretty not interested in, only sort of 9% of you there. But for the rest, it's a kind of spread. This tends to happen with this quiz. People sort of kind of give up and just start guessing randomly at some point. That's actually a good thing to do. Okay, guess if you haven't already. I'm going to close the question in 3, 2, 1, and it's closed. All right, so what are we saying? We're not awfully confident about AB, low confidence for A space B, pretty confident on B, not so confident on A. The correct answer, it's A. This is a weird rule with HTML. I think a lot of specs on the web, it will tend to take the last valid value. That's certainly true in CSS. But for attributes, it's the first one, and then the rest are ignored. All right, devices at the ready. Next question. OK, this is involving some newer features on the web. According to the spec, not necessarily the browser, according to the spec, which of these scripts will execute first? Actually, I think most browsers get this right according to the spec. But what do we have here? We've got a script with a source type module. That's a new thing. We have an inline script type module. We have an inline script with the defer attribute. And we have an inline script, an external script there with the defer attribute there as well. But which one is going to execute first? Oh, OK, I was expecting more of a spread of answers here, but there's Sort of high confidence on 2 of them, low confidence on the middle ones. Really curious to see which way this one is going to go. Get an answer in if you haven't already. Make sure you hit the submit button. Closing the question in 3, 2, 1, and we're closed. Right. Okay, so low confidence on 3, lower confidence on 4. Oh, I'm very sorry. It's 3. Number 3. Okay, so why does this actually happen? So here we have a module script, one of these new script types. Now they are defer by default. It's implicitly defer. So that's added to the defer queue. This inline module script, once again, added to the defer queue. That's implicit. So here we have a standard inline script with a defer attribute. It totally ignores the defer attribute on inline scripts. That's only just started working with modules. So that sees it just as a normal script, and it executes it straight away. So that's why it happens first. This one is also added to the defer queue. So the order that will be executed is 3, 1, 2, 4, with 3 first. All right, next question. Here we go. OK, I like promises. So here's one about promises and microtasks. And, well, this is just promises. We've got a microtask one later or maybe tomorrow. Which of the following promises reject? So we've got promise.reject false there. 2 here, we have a promise reject, and it's past a resolved promise. 3, we have a promise.resolve. It's past a rejected promise. And number 4, we got promise.reject, but we're adding a catch on the end there. Select all that apply. Make sure you hit the submit button. All right. Oh, so we're kind of seeing people going towards 2 answers once again. So the high confidence, although the blue one there is dropping rapidly. Do get a guess in if you haven't already. So I'm going to close the question in 3, 2, 1, and we're closed. All right. OK. So as a room, you're saying 3 is the most likely one to reject. Less confident about 1. The answer. All of them. They will all reject. Sorry, I know this is a really evil quiz. But if you're having a low score on this, it doesn't mean anything. This is all the weirdest corners of the web. Don't worry about it at all. OK, here's what's happening. Promise reject false. This will create a promise that rejects with the value false. This here will create a promise that rejects with a resolved promise, but it still rejects. This one here, now this is the weird one. Promise.resolve, it creates whatever you pass to promise.resolve, it will resolve with that value unless you pass it a promise. And if you pass it a promise, it will copy whatever that promise does. So that's why this one also rejects. This is a cruel one. If you catch a promise, it will resolve rather than reject, but you have to pass a function in. If you don't pass a function in, it will remain rejected. It just acts as if nothing's happened. But if you did pass a function in, even an empty function, that would resolve. All right, device ready, next question. OK, so from this piece of code here, how many elements are created as this code runs? So we're inner HTML equals, and then from then we're plus equals, plus equals, plus equals. Does it create 1, 4, 10, or 16? Select 1 and hit the submit button. Ah, this is good. We've got high confidence on 1 answer here. That's what I like to see, but will it be the correct one? I guess we'll find out. Take a guess if you haven't already. It's always worth taking a guess. I'm closing the question in 3, 2, 1. And it's out. OK, so most of the room saying, oh, 4 in the end. It actually switched places. So 4, 4, and 1. The answer, I'm sorry, it's 10. And here's what. And this is a piece of code that I used to write code like this, and I didn't realize how much of a performance problem I was creating for myself. Here's what happens. So when you do this, you're passing code to the HTML parser inside the browser. But because it's plus equals, that actually just desugars to the thing plus the thing, like that. So you're asking the browser to serialize the DOM, you're adding more string to the end, and then you're asking it to parse it again. So it actually creates 1 element, 2, 3, 4, 5, 6, 7, 8, 9, 10. There'll only be 4 there at the end, but you've created 10 elements in doing that. So I would avoid that and instead use insert adjacent HTML, and that will do the right thing. It will only create that many. All right, I'm running out of time, so I'm going to pick a favorite question to go next. Oh, yeah, let's do this one. This is fun. OK. Right, devices at the ready. Here comes the next question. Now, this is the evilest one I've got. It's promises again, and it involves microtasks. So we have 2 event listeners on the same button, but when the user clicks that button, which logs first? Does it log 1, 2, 3, or 4? There isn't even a 4 there. How could this possibly work? Or maybe when I did the design, I assumed I would always have 4 answers. Maybe that's what's happening. Anyway, get your guess in. Let's have a look at how the answers are shaping up. Oh, OK, we've got a smart room here. There's high confidence for one of the answers. All of the rest of them, not so interested in. This is the last question, so just take a guess if you haven't already. I'm going to close the final question in 3, 2, 1. We can all relax. OK, so what we're saying 3 is the one that is going to be logged first. I'm sorry. The correct answer is 1. And this is something I only learned relatively recently. Let's take a look at some of the code. Oh, my code's not appearing. That's fun. Why is that happening? OK, so what I'm going to do is describe it with words. So what happens is when you're running when you resolve a promise, it queues as a microtask. And at some point later, the browser is going to handle that microtask queue and do something with it and start executing those things. And the time that it does that is when the JavaScript stack empties. So when we run that first listener, that function runs, it queues a microtask, and then that function has done running. The stack is now empty. And because the stack is empty, that microtask is going to run, and that's why 1 is logged first. And then it will handle the second listener, where it will log 3, and then the microtask is queued, and it will log 2. So the correct order is 1, 3, 2. That actually changes if you ask the browser to call the click function. Like if you do element.click, then the order changes because you have that .click function, that function call on the stack. So you'll actually get the answer most of you came up with, 3. That will be the first one in that case, but only when you do that. OK, so my slides have gone weird, but let's see if I can call up the scores. Can I do that? Yes, I can. So here are the final scores. Oh, we've got joint first place. So absolute congratulations to you two. A huge round of applause for everyone in the top 3. And I am standing in the way of you and your after party. So if you're interested in doing more questions, I'm going to be here roughly the same time tomorrow at the end of the day with a new set of questions. So if you're the kind of person who enjoyed this, then you can come back for more. But go and enjoy the after party. Thank you very much. Bye.
Thank you, everyone, for joining us on day 1 of Google Developer Days India. Just a quick reminder to hold on to your badge and bring it with you tomorrow for more sessions. And now, please join us in Hall 3A in the Sandbox area for the after party, where we are thrilled to have the Raghu Dixit project perform, as well as DJ Hussein, and plenty of food, drinks, and games. Thank you so much. Dude, that was ace right there.